hey, do you want to install the newest version of Create ETH? You want to click yes. Obviously, I already have that done, so it didn't prompt me for that. But then you can just name your project. So you can just say, we'll say Istanbul. And then it's going to ask you what chain you want to use. So if you're familiar with Hard Hat, you can choose Hard Hat. If you want to write your tests in like Solidity, then you probably want to use Foundry. It's really just up to you. I personally still like Hard Hat, so I'm just going to go ahead and say Hard Hat. And then it's going to ask you if you want to install the packages. So this is going to download Scaffold-ETH automatically, kind of like bootstrap the environment, install all of the dependencies with Yarn, and then also initialize a Git repository, so then you could just check it in your own Git configuration. This takes probably about a minute, depending on the internet connection. Hopefully there's not a bunch of hackers right now downloading packages, and we can get started here quickly. But yeah, so this is, it's going to install everything you need to get started. Let's go ahead and give that just a second. While that's installing, the other option, like I said before, is you can just go to Git. You can clone the repository. I'll talk really briefly about the requirements. You need Node.js installed on your computer, obviously, and you need a Yarn package manager. Make sure you're using like a newer version of Yarn and not like the old one. Like if you're running Linux, sometimes there's some old version of Yarn that gives issues, so just update it. And then obviously you need Git. And all the instructions that I'm going to go through are in the GitHub repo. And I also did a really good workshop that you might want to check out that kind of shows how you can do a graph integration as well. And this is available at bit.ly/fullstackdApp. And it kind of walks a little more in depth on how you like do some of the full stack stuff. Because of time today, we're going to try to get as far as we can, but we'll go from there. So it is still installing. So I knew that might be a problem, so I actually went ahead. Oh, there it goes. Sweet. All right, so it scaffolded everything for me, and then it just tells me, okay, what do I need to do next? Well, I need to go into the Istanbul directory, and then I need to run my chain. So everything it's a Yarn mono repo, so it's designed with this concept of like, just yarn this, yarn that, and there's all these scripts that are already written for you to do things easily. So I'm using Tmux, which basically allows me to kind of split my screen up. If you aren't using Tmux, you can just do this in like separate windows. So if you see me kind of breaking stuff up, that's why. But Yarn chain is going to do that. It's going to spin up your chain. So it's going to spin up Foundry or Hard Hat, depending on which one you chose. And then it's going to spin up, obviously, the accounts that you can start testing with. And all of the associate private keys are there, so you could like copy and paste those into MetaMask if you want to do or something. But then in the second window, we're going to do Yarn start. Okay? So Yarn start is going to spin up the front end, which is basically React with Next.js. All the code is pretty much written in TypeScript, but you can also write JavaScript as well. TypeScript's a little bit better in my opinion, but it is up to you. So that's it. So now the front end's up. And then in this next window, same thing, we're going to go into the Istanbul directory and do Yarn deploy. So Yarn start, Yarn chain, Yarn deploy. That's kind of like the pattern. And we can see here that we basically got the contract deployed, and we see some output on console log, which is from Hard Hat. And we see that our front end recompiled, and we see that we get a contract address, and it told us how much gas we used. So there's a lot of cool output that we get, how many Solidity files were compiled, and then our contract's been deployed. So let's take a look real quickly, briefly at the code and show this. So it's a mono repo. So there's two packages. There's Hard Hat and Next.js. The Hard Hat directory is going to have the contract in there in the contracts folder. And so we can come in here and see it's a very basic contract that comes with Scaffold-ETH. It's basically this kind of greeter. We call it a greeter, or like a hello world contract that keeps track of a greeting, right? There's some other stuff here. I'm not going to get too much into that. But for the most part, it's a very basic greeter contract. It also has a modifier. It also has a function to update the greeting. So you can pass in a new greeting, and then you can also make it's payable, so you can send some funds. But it's got this stuff in here. So let's take a look at Scaffold-ETH real quick. So let's load up Scaffold-ETH on port 3000. This is Scaffold-ETH. So the first thing you'll notice is that you get this kind of like hello world page. It's like the index.tsx file. This is kind of where you're going to want to build your app out when you start hacking away. And you can kind of think of it like as the home page, and it's like going to be your dApp inside of Scaffold-ETH. And that way you can keep the header, you can keep the footer, and then you just build around it inside of this index.tsx file. And we'll get to that in a second, but I want to talk about this debug contracts tab. This is kind of like the sweet sauce of Scaffold-ETH, and it's what's really cool is every time that you do a yarn deploy, you generate an ABI, right? So what Scaffold-ETH is doing is just reading in the new ABI every time you make a change to your smart contract and then automatically building a UI for you. So this is really useful because you don't have to start, writing React code. I don't know, who here's a React developer? Few. Most people are like, oh, I don't want to touch React unless I absolutely have to. You want to experiment on your smart contract. That's the fun stuff. And so this is cool because it just creates these things for you. So we already know without looking at this contract that there's a counter. We also know that there's a write function that allows us to change the greeting, and it accepts value. And then there's a withdraw function. And we see all of the variables here as well. And then up here in the top, you'll see there's this connect wallet option, but there's a burner wallet option. So the burner wallet is cool because, like, let's say I want to change the greeting to Istanbul, like this, and I hit send. It's going to tell me I don't have funds to pay for that transaction. I can just grab some funds inside of the burner wallet. I don't even need to connect MetaMask, which is really useful because MetaMask can give you these like nonce errors when you're deploying locally. So yeah, you got everything you need here, and then you can do the transaction. And then there you go. We updated the state of that greeting. So, and then you get a receipt, right? So you can see like basically what happened with the transaction. You can see like if there was any issues or something like that. And then we also have this withdraw function. So if I was to send some value in here, we could say like 0.05 ETH. Now you'd think you could just hit send. That's going to tell me, well, it's a big int, right? If you've done some Solidity stuff, you might know that you need to transact in Way. So there's this cool button here that will do the math for you. So it will multiply what you want in ETH times 10 to the 18th power, and then you can just transact in Way, right? So it's a really cool little developer experience, and then we hit send, and then it was successful. And then we can see here that our contract has a balance as well. So we're getting the contract balance as well. So everything's really intuitive and fluid and easy to do. And then you would also see this withdraw function. So let's try to hit that. It's going to tell me I'm not the owner of the contract. So who's the owner of the contract? Does anyone want to tell me what this address is?
It's
Yes. In the front. Round of applause. So that's the hard hat account. So the reason why that's important is if you first start messing with Scaffold-ETH, you'll be like, who owns the contract? Well, there's a deploy script right below the contracts folder. And here, we basically get a list of all the named accounts right here. And then we do the deploy, and we pass in an argument as the deployer. So because if we look back at our smart contract, there is a ownable kind of, well, not ownable, but there's an access control pattern in here. It's kind of hard-coded. You probably want to use ownable here from OpenZeppelin, but we've kind of like hard-coded one in where we actually pass in the owner of the contract here. We have our own little modifier here, and we're basically checking for that on the withdraw function. So if we go right here, it says, well, you have to be the owner, right, of the contract. So the reason I'm saying that is you can come in here, and you can grab your burner wallet, so we can copy the address, and then we can just paste that in here, save it. Now we can redeploy. So now if you want to redeploy, you can do yarn deploy again. If you haven't made a change to your smart contract, you'll notice that it doesn't compile. And that's because it just detects that. If you want to force a new contract, you can do -- reset, and it will always force a new contract. And so that's really useful if you just want to reset everything and kind of guarantee that you get a deploy. You'll notice that you continue to kind of keep getting a new contract. So now if you look at the owner, it matches the burner wallet, right? So we have this thing. So if you're about to launch to a testnet, you probably don't want hard hat to have access to the contract. You probably want to have your own deployer account, which we're going to get to in a second. But now we were able to do that. So now if I actually do some value, so first of all, I want to bring up a new incognito window. And if I'm going too fast for people, this has been recorded many times. And it also is live streamed, so you guys can go back and watch it. Or I'll be here to answer any questions you guys have. But if you notice in a new incognito window, I get a new burner wallet. So I can come in here, grab some ETH, change the greeting to yo, what's up, like this, send some value. I could send 0.05 ETH, send. And if I try to withdraw here, it's going to say I'm not the owner. But if I come over to this one, now I can like refresh, come to the bottom, I see there's a balance, and I can withdraw it. And it was successful. So you can kind of start messing around. You see how we start tinkering around. And yeah, so the next thing I want to talk about is if you want to take your contract from here and then you want to like push it to a testnet, because like local stuff is great, but at some point you're probably going to want to collaborate with your team. You don't want to use the hard hat accounts to do that because those are shared hard hat accounts. Everyone has the same private keys. And so the minute you try to fund one of those accounts to do your deploy, it's going to fail because someone's going to withdraw all the funds from that deployer account. So there's a function in here where you can do yarn run generate, or I think just yarn generate works too. But what it's going to do is it's going to generate a private key for you, a deployer account in the environment file locally. And then it's going to give you a public address. So then you can basically take that and you can fund it. So let's say we want to deploy to Sepolia right now, right? So we can do yarn account, and we can kind of see what's going to pop up here. It's going to bring up a QR code for us, so we could like scan it on our phone if we had some testnet funds on our phone. And then it's going to give us a public address, and it's also going to go out and check balances for all the accounts, okay? So we could take this address now, because this is the account that I just generated. I could come over here to MetaMask if I have some funds in my MetaMask, which I have a lot. So I'll send some Sepolia ETH. I'll send 0.05, sure. Okay, next. Confirm. So maybe I was able to send this from my MetaMask to my deployer account. And if we just give that a second and then do another yarn account, and then we can see. I hope that was on Sepolia. Was it? It was mainnet. No. Yeah, it was. Let me just make sure. Yes. Okay, so there it is. So the balance has been updated. So we see here that we get a balance, right? 0.05. So now what we can do is do yarn deploy -- network Sepolia. So that's going to take our contract. It's going to see that there's nothing to compile, but it's going to deploy it to Sepolia for us using that deployer account that we generated. So a really seamless experience to start writing a contract, deploy it to the testnet, and obviously that's going to be a lot slower than hard hat, so we might have to wait just a second here, but we will give that a sec. There it goes. So now it deployed. So we've deployed our contract, so we have the address here, right here, so we can look it up on Sepolia Etherscan. And we can paste it in and see if it deployed, right? And now the contract is deployed. It was deployed 19 seconds ago. But if you look right here, it's also already verified. But chances are your contract is not going to be verified because you probably have made some changes. I didn't do any changes to my contract. But if it wasn't, there is a yarn verify -- network Sepolia. And it will take the contract, compile it, and then compare the bytecode with Etherscan to verify it, basically to make it trustworthy, and then it's going to give you that green checkbox. So the reason why that's important is if you're going to go for the graph bounty, you probably want to create a subgraph for your contract, and you'll want to have the ABI on and available in Etherscan. And so that is a real simple command to do that, and then you'll be ready to do the graph bounty. So you guys can get 2 things for 1. Okay, so yeah, so that's already verified. The next thing we want to look at is like how we update our front end a little bit. So I only have like 5 minutes, so this is like speed run Scaffold-ETH. So we look in the Next.js folder. I'm going to briefly touch on it, but there's a couple config files. The first one is the scaffold config. So if you come here, there's a chains.hardhat, so we can change that to Sepolia and then save it. And then if we come back to Scaffold-ETH and refresh, we'll get kicked out of our burner wallet here, but then we can connect MetaMask. So we can say MetaMask, now we're on MetaMask, and I have my contract on Sepolia right here. The network's been updated. So now I'm ready to interact with my contract on Sepolia, right? So I could set a greeting to ETH Istanbul like this, hit send. It's going to ask me to pay some gas. This is going to be an actual transaction that I'll have to sign. So we were able to update our front end, deploy a contract, do that kind of stuff. And then we could also deploy, if we wanted to take this and share it with our teammates, we could do a yarn Vercel. That's going to basically package up the entire front end for us. Set up and deploy, yes. Which one do I? If you haven't logged into Vercel, it's going to ask you to log in or create an account here. It asks you if you want to link it to an existing project, what you want to name the project, where the source code is. It's going to set it up and then upload it for us. So it's going to actually deploy your front end and then go from there. So really seamless experience to then take your app and put it on a public web server that you can then share with your team and start doing some more collaboration. So it's building. This might take a second, so I'm not going to stick on this. But just so you know, at the end of this, it's going to give us a URL that we can access our DApp, and any of you guys could have been able to go there. I want to touch on a couple other things real quick because this is really important. So inside of the pages directory, there's an app TSX directory. This is kind of like the main app file for Scaffold-ETH. But if you look into the, see here, index TSX file, this is probably where you want to start building your app. Scaffold-ETH uses WAGMI, and it also uses RainbowKit, and it uses TypeScript Next.js. And it has a bunch of hooks and components available already. So first of all, you can use WAGMI to get the account information or to get balances or whatever you want to do. All of the WAGMI hooks are listed on the docs for WAGMI, and they're available here instead of Scaffold-ETH. So if you want to start doing front-end stuff, you can reference that. And then if you go to docs.scaffold-eth.io, there's a section that talks about all the components. So like there's an address component, so you can get this kind of like pretty little ENS resolution with the copy button. There's also a balance, so you can get like a pretty balance that you can convert from ETH to US dollars just by clicking. There's an address input that does ENS resolution, right? So you can type in an ENS name and it will resolve it for you. So there's a lot of these components built in. And then there's also Scaffold-ETH hooks. So if you go here to Scaffold-ETH hooks, there's a hook that allows you to read from your smart contract. There's a hook that allows you to write to your smart contract. Like here you can pass in some arguments. Like maybe you want to set the greeting and then you need to set the value as an argument. So everything's written for you to make it easy to actually start writing your front end. And it's pretty seamless to do. Normally at this point I would start kind of showing you guys how to write some front end stuff, but I think the docs is really good. And I think there's lots of examples there. You guys won't need that. So I have 1 minute for questions. So anyone have a question? Yeah. Yeah, I can. I'm sorry, I can't hear you. Can you speak up? Can you, display the transaction receipts in the UI? Yeah, you should. It comes back as an object. I don't know if there's a hook for that. I mean, I know you can like look at events. Oh, like the actual like drop down thing?
The pull down like.
Yeah, I'm not sure where that is. I'd have to look, but let's connect offline and I'll look it up for you.
Yeah, the other question is, can you deploy the contract in a multiple chain with the same address from the
I'm sorry, can you speak up? I can't hear you, it's really hard.
Can you deploy the contract into the multiple chain with the same address from Scaffold?
Multiple chains, no, we don't have any support for that. It would be a single chain. So you could, I guess technically you could keep deploying to multiple chains and keep updating them or like just use different commands, but the UI can only point to one chain. You'd have to create a fork of Scaffold-ETH and build something cool like that, but that would be awesome, so yeah. Yeah, I'll hang out here for a little bit. I'm going to be at the Graph booth, of course, because I work for the Graph, but just come find me. I'll hang out a little bit so we can answer questions. I'm sorry, we don't have time for questions, right? Because there's another person. Yeah, sorry, guy. I'll hit you up after. Yeah.
Vitaly. We will present to you, I will talk a bit about the Fatom protocol itself, what it is, what's the architecture, how it's structured. We'll guide you through our repositories, and then we will have maybe a short demo from Vitaly about our CDK. So let's start. Today we will talk again about the protocol overview, about stablecoin features. Maybe we'll have time to show the small demo, and we'll try to have some couple of minutes for questions. So about the Fatom protocol. Fatom protocol has several components. The first two are our main products, Fatom stablecoin and Fatom DEX. We plan to release more parts of our protocol in not far future. We will release vaults, we will release full-scale lending, we'll onboard new collaterals, so we'll have more updates soon. Fatom is also the decentralized protocol. It's governed by DAO. DAO governance is based on ETHGlobal token, which is only the governance token and can be used, for anything else. Users can get voting power and vote for protocol changes, for collateral onboarding, and so on. In Fatom, we have the goal. The main goal is to bring real-world assets on-chain and make them more accessible. As I said, Fatom governance can vote not only for protocol updates, it can vote also for collateral onboarding. We'll have our own also tokenization system, but mainly we will accept ready tokens from the partners. ETHGlobal stakers also will have possibility to get incentivization through the staking. Let's talk a bit about FXD stablecoin. FXD is the heart of Fatom, and we hope it will be also the heart of the DeFi ecosystem on XDC chain. XDC is layer 1. It's EVM, very cheap and enterprise focused. A lot of partnerships here and there. They already have USTY, it's a US Treasury bond. It will be available on-chain in upcoming month or two. They have tokenized gold and many more things, which we also plan to use in Fatom. So FXD is collateralized stablecoin. It operates pretty simple. Lenders can deposit their collateral. Initially XDC coin, which is coin of the XDC chain, to borrow FXD. So each FXD issuance is backed by collateral exceeding its value, safeguarding against market volatility. FXD is always pegged for $1. Well, it targets to be pegged to $1, of course, maintaining a steady value. The peg, what helps the peg is also our stable swap model, which initially facilitates the swaps of FXD to another stable currency at 1-to-1 rate. If FXD price goes above $1, minting of the new FXD will become more attractive, which will induce a selling pressure to restore the peg. And if FXD drops below $1, buying of FXD to close borrowing positions becomes favorable, creating a buying pressure to realign the price. So we have like three ways how we can maintain the peg: liquidation system, stable swap, and market arbitrage opportunities. For liquidation, we are using a fixed spread liquidation model, which is broadly used by Aave, for example. Compared to MakerDAI, we have this strategy. MakerDAI has auction model. How fixed spread works? It is activated when FXD price, when XDC price goes down and FXD position requires to be liquidated due to the price drop. So we are ensuring the effective liquidation with minimized cost to, to protect from bad debt risk. So for price drops, position becomes eligible for liquidation, and liquidator can come and liquidate the part of the position, taking back the collateral, and on a slightly better price than on the market, which is spread. So yeah, you can see here the architecture of the stablecoin of the Fatom. We have in the very core the stablecoin. We have arbitrage through DEX and through centralized exchanges. We have liquidation model, which is updatable, and we will update our liquidation in future. And yeah, let's not talk about governance for a bit because it may be boring. We'll just say yes, we have the governance. We have the ETHGlobal governance token. Let's talk about the platform. You can go to diab.fatom.fi on XDC network or to demo.fatom.fi on Apothem testnet. I will show you a bit of the flow on the mainnet. So here you can see the interface of the Fatom. You can see the available pools. We'll have more available pools on this in future, and you can decide to open your position. You can utilize your XDC. For example, I want to bring 500 XDC into the platform, and you can click on the Save Max button, which will give you the borrowing amount which we consider the least safe to borrow. You can go more, for example, to let's say 15, but it will show you, hey, safety buffer is not so big. You can see the safety buffer here. We consider safety buffer safe to be 25%. You can go up to 0%, but not much above. Means if safety buffer is negative, you cannot borrow. You can choose to have a better safety buffer, but it's always up to the user. Let's check if I can mint something. Oh well, all right. I can do the minting only on Apothem. So I switched to Apothem testnet. Here we have some accounts already ready. I'll connect my wallet, which tells me the wrong network. Yeah, here you go. You can see the list of my already open positions, and as I told you, I will open one more. The block time on XDC is 2 seconds, so transactions will be pretty quick. And here you can see the recently opened position with 500 of collateral and about 16 FXDs borrowed. And you can utilize this stablecoin in DeFi. You can utilize it in our future vaults. You can utilize it already in our partners' network of staking, where you can put your stablecoin and get yield on it. And if your position again will become unhealthy, somebody can liquidate it, or you can close it by yourself to manage the risk. You can top up position if you want to borrow more, or you can repay it. Let's try to repay it fully. And it's done pretty easy, pretty simple. So we incentivize on this hackathon hackers to start building DeFi ecosystem around stablecoin, around FXD on XDC network, because it's just the beginning of the DeFi ecosystem on this layer 1. You can go to our resources in ETHGlobal to check. We have pretty much resources there. XDC documentation, Fatom documentation. We have some SDKs ready for you to use. So for example, let's go. Vitaly will talk a bit about Fatom SDK for front-end application in a while, but we also have the Solidity SDK, which you can use to easily connect to FXD smart contracts and do operations with stablecoin, borrow it, repay it, and so on. We have how-to, the interface of this proxy smart contract, which we offer you to use, but you can go to our repos and use them directly, of course. So here we explain the process, how to create a proxy wallet, how to open position, how to check the information about position, how to close position, and so on. We have everything open sourced. You can check it in our repositories in GitHub. We have a lot, Fatom SDK, Fatom stablecoin smart contracts, and other smart contracts and our front-end application. So I don't want to consume much more time. I want to offer Vitaly some time to explain how to use our front-end SDK written on TypeScript in your applications, please.
Hi, my name is Vitaly. I am front-end lead engineer, and I want to present our Fatom SDK. It's built so it relates with Web3.js, but XDC network has some specific prefix, and for work in XDC network, you need some fork library of Web3.js, which calls XDC3.js. So first of all, you need to install this library with npm install XDC3, and our SDK required to have instance of this library, and you should put some provider and some chain ID to our service. So here is example of one root service, which includes every service, and we use this service to do a transaction and retrieve on-chain data for our FXD, also for DAO proposals, for staking, and also we have service for opened position. And here you can see list of all methods, which includes each service, and you can understand what exactly this method do. And also this SDK includes all necessary addresses, all necessary APIs for communicate with our smart contracts. So if you want, you can find this package on npm, and you can see example. It detailed example how to use our services, and you can also find all methods which each service include. So this is base information. Maybe you have any question?
I want to finish this speech by saying a couple of words just about the hackathon. So again, you can check this page for our prizes. We incentivize to build almost anything you want. Just please build it on Apothem testnet or XDC mainnet. And please utilize Fatom FXD stablecoin in your applications. Here you can find some ideas what you can build, but you're eligible to do anything. So thank you very much, everyone. You have the questions? One.
May I ask you if you take questions outside? I'm sorry, because we're not on time.
Yeah, of course.
So sorry.
No problem. Thanks, everyone. Let's build together. Yeah, do I need just to disconnect?
So, hi everyone, my name is Miro. I'm an integration developer at Neon EVM, and today I will show you a very cool demo of how we can support a single token existing natively on both chains of Neon and Solana without the need of always bridging when you have to interact with a contract from the other chain. But first, 2 or 3 words about what is Neon EVM, what are we doing. So basically, Neon EVM is providing a solution which is combining the adoption of Ethereum tools and Solana's fast and cheap transactions. So Neon EVM is not a sidechain or a layer 2 protocol. It's actually much simpler. It's a smart contract living inside Solana. So basically, how we managed to support the entire EVM inside Solana? Well, basically because Solana allow us to store a bit more executable data compared to Ethereum. I think it's somewhere around 10 megabytes, which is pretty much enough to store the entire EVM. Basically, we call it Neon Proxy, but it's basically Ethereum-like RPC, which is listening for Ethereum-like transactions. And basically what happens is when such transaction appears, our Neon Proxy unwraps it and wraps it again as a Solana-like transaction. And because we rely on Solana, beside the fast and cheap transactions, we also benefit from the parallel execution of the transactions, and which means that all of the transactions run on Neon EVM are basically getting executed in a parallel way instead of sequential way. And this is also happening because Neon is stateless, which means that the contracts on this is also happening because the contracts on Solana is stateless because they do not hold any state, but they hold only their executable bytecode. One more thing to mention is that we also support the majority of opcodes. Next thing, yeah, so basically Neon EVM is a very easy way to use your Ethereum stack and use it to deploy on Solana. You can use pretty much all of your most famous Ethereum stack like Foundry, like Hardhat, like Solidity, Viper, even the most famous wallets such as MetaMask, WalletConnect to basically deploy on Solana, which is pretty cool because me personally, as a Solidity developer, I don't have to change my stack at all to deploy on Solana and benefit from the fast and cheap transactions. Yeah. Now going back to my demo today, I will be showing you a standard of ours, which is called ERC20 for SPL. This is like the first use case of how we can support Neon contracts interacting with Solana natively. So first, we will be using a Hardhat, one of the most widely used frameworks for deploying on Ethereum. In Hardhat config, we have defined two networks, which is first the Neon DevNet, the second one is the Neon mainnet, and for the demo, we will be using the DevNet one. Now going to walk through the contract. As you can see at the top, we have defined basically using two libraries out of the Open Zeppelin package. This is pretty cool because just the other day I saw some random developer on the Solana forums asking, is there something like Open Zeppelin but on Solana? And of course there isn't currently, but this is an option now how to basically use Open Zeppelin and deploy on Solana. The next two more interesting stuff are these two interfaces. So basically, what is a SPO token? SPO token is the equivalence of ERC, but on Solana. It's a bit more different because currently in Ethereum, we have a different set of standards like ERC20, ERC721, and so on. But in Solana, it's a bit more centralized when it comes to this because there is like one central registry. And this central registry is the protocols of SPO token, which is used to deploy basically any token on Solana. So yeah, that's pretty much for SPO token. As you can see here on this line, we are creating the interface for the SPO token registry. And this metaplex right here is basically a set of protocols which you use on Solana. For example, when you deploy a new token on Solana, basically use metaplex to attach some metadata to it, such as a token name, token symbol. For NFTs, you can use also royalties, fees, and so on. And going down to the contract, you can see that we support pretty much the ERC20 interface. We have name, symbol, decimals, balance of transfer form, but I want to pay more attention to these two methods. So basically, approve Solana and transfer Solana are pretty much the same thing as transfer or approve in ERC, but the only difference is that this will be used in the case where the receiver doesn't have a Ethereum-like wallet, but he has a Solana-like one. So basically, you can see that the two parameter right here is not in a type address, but instead is in bytes 32, which is actually the Solana address, and encoding this value into base 58, it will return you the raw public key of Solana. One more method that I want to highlight here is this one, the Solana account. Okay, so one important thing to mention is that when you interact with the contract for the very first time, behind the scenes there is a Solana key pair creation for your Ethereum-like wallet. So, but this is only happening the first time, and this is why the first transaction is a bit more expensive. But once done that, you don't have to do it always. And yeah, I will show you in a bit how is this happening. Going through my deployment script. So the deployment script is very, you can see it's very basic one. At the top, I have defined two users for the demo. This is my deployment script of the ERC20 for SPO. One thing worth mentioning here is that this is the decimals of my contract. So because the end goal here is to deploy on Solana, basically we have to adapt with the Solana limits, and currently you cannot store more than a bigger value than UN64, so you are limited to using 9 decimals. Here, a bit down, I'm minting the first tokens to the owner, minting 1,000 tokens. Then, a bit down, I'm initiating 2 transfers. They're pretty much the same, with the same message sender, with the same receiver, and the same amount. And I will show you why I'm doing this. And at the bottom, I'm just displaying the Ethereum-like and the Solana-like wallet addresses for each one of my users in this demo. Okay, let me just run my deployment script now. As you can see, the command is nothing special. It's just like a usual way of deploying through hard hat, just with the different network, which is Neon DevNet. Okay, we see that our proxy has been minted. We see at the beginning that nobody of the user has a balance. By the time of the minting, we have minted 1,000 tokens to our owner. And then after doing the 2 transfers, our owner is left with 800 and the user is left with 200. And these are also the Ethereum-like and the Solana-like addresses for each one of the users. Now, if we check this proxy in our DevNet Neon scan, yeah, we can see the proxy has been deployed successfully. Now, if we scroll down to the transactions, we can see this is the first one, which is the deployment. The second is the minting to the owner, and third and fourth are the transfers from the owner to the user. The first one, here the more interesting stuff is, for this Neon transaction, we actually have 4 different Solana transactions, and this is happening because what I did mention in the beginning is that we have our Neon proxy, which unwraps and wraps transactions, but there are differences in the limits between Solana and Ethereum-like chains. Basically, if most of you should know that in Ethereum, you don't have like a memory limit of your transaction. You're pretty much limited by the block gas limit, but in Solana, it's a different story. You are limited by a bit more than a kilobyte. So in this scenario, if our Neon proxy has taken this Neon transaction and submitted it as one into Solana, this was going to revert. But because Neon proxy was smart enough to see that, okay, this is not going to work, it splitted the main Ethereum-like transactions into 4 smaller Solana transactions. Now, let's look at the other two transactions. Yeah, this is the minting, as you can see, minting from 0 address to our owner, 1,000 tokens. And the next 2 transactions are the 2 transfers, which are pretty much with the same data. So this is the first transfer, and you can see that the fee currently is 0.26, and for the second transfer, the fee is 0.001. So the difference is more than 200 times, and why is this happening? Let me show. This is because what I have mentioned earlier, behind the scenes for your very first transaction, there is a account creation for your Ethereum-like wallet. So going now to Solana scan and scrolling down to the instructions, we can see that, okay, there was a token transfer with amount of 100 tokens, and this is our source, this is our destination. And if we double check our Solana-like wallet addresses, we can see that the destination is our, the source is our owner, and the user is our destination. But why is this transfer a bit more expensive? Actually, not a bit, but 200 times more expensive than the second transfer, is because this user address has never yet interacted with the Solana contract, and basically the first transaction is like initialization one. As you can see, we have a instruction here, which is initializing the Solana's account for the user. And in the second transaction, you can see that there is no such thing. I mean, once you do it, you don't have to do it twice, and this is why this transaction is 200 times more cheaper. Basically, this is only the token transfer. So yeah, that was pretty much our first use case of how we can have Neon contracts interacting natively with Solana contracts. Another use case would be, okay, for example, in Solana there is a Chainlink deployed with different price feeds and so on, and because it is deployed there, we don't have to deploy it also on Neon. We're basically taking the price feeds directly, natively from Neon to Solana. One last thing before I finish my demo. guys, we're live on mainnet since this July. We have like a different set of products, like the EVM that I just mentioned, which is a smart contract inside Solana, the proxy server, which is smart enough to unwrap and wraps again transactions, the tracer API, which is getting a huge update very soon, which is helping developers to debug their stuff, the Neon Pass, which is our native bridge between Neon and Solana, the Neon faucet for sending testing amounts to users on the DevNet so they can play around with their stuff, and the Neon DAO, which is our governance. So yeah, that was pretty much about my demo for today. Please join us, give it a try, and start building your stuff. Thanks, guys. And yeah, thank you. And one more thing to mention is that we have our hackathon today and tomorrow. You can join up and try to win some rewards. The second one is very cool. We would like you to basically destroy our DevNet. We want to see how much it can handle. Yeah. So yeah, any questions so far? Okay, if you have some questions, just find me somewhere here at the event and let's talk, yeah? Yeah, that was a deploy on Solana through Neon by using Hardhat, yeah? So currently you cannot rely on any of the Ethereum state. We don't rely on that. We only rely on the Solana state, yeah? Yeah, but basically you can use any kind of Ethereum stack to deploy. Basically, Neon EVM is like taking your Solidity bytecode and transferring it into Solana. Yeah, okay. Yeah, no more time for questions. Thank you, guys.
Everyone, it's great to see you here. Let's talk interoperability. This workshop's about Hyperlane. Title is Hooked, Building with Hyperlane V3. I'm Daniel, I'm a software engineer. Hyperlane's main features is really twofold. So the first one is modular security of sending messages cross-chain. And the second one is permissionless interoperability. So really anyone can take Hyperlane and deploy it between any chains, 2 or more, without asking us for permission or without having us run their infrastructure. To give you an overview of Hyperlane, you want to send a message between 2 contracts that live on different chains. So you have chain A and chain B. The way you do that is from the sending contract, you call this mailbox contract that lives on the origin chain, and you send a message to it. There is an off-chain agent called a relayer that periodically scans the mailbox on the origin chain. And when it finds new messages, it will look for their destination chain and deliver them to the mailbox on the destination chain. Once arrived there, every message can have a different security configuration based on who the receiver is. So the message has to pass through this interchain security module logic. This logic can, for instance, be a multi-sig, like have enough signers sign this message for it to be considered valid. And if it is considered valid, it passes the interchain security module verification. Then the message is forwarded to the receiving contract. Currently, the status quo of interoperability is that if you integrate with a bridging provider, so with their messaging interface, you are tied to whichever security module they choose to use. So later on, if your security matures, or like if there's new products on the market that improve interchain security, you're not going to be able to just upgrade the security of your bridge without breaking the interface of your contracts and having to release a new protocol version. So the first innovation that Hyperlane brought about is to decouple security modules from the messaging interface. So all you have to do is just integrate with a Hyperlane contract, and your message can have its security module decided dynamically based on who the recipient is, the content of the message, and so on. The way this works is that once the relay calls process on the destination mailbox, the mailbox will then query the recipient for the interchain security module it wants to use. It will then feed the message into the interchain security module, and if it turns out it passes security verification, the message is forwarded to the recipient. This allows you to do some really powerful semantic routing, which is, for instance, if the message is low value, you might be happy with a quicker and cheaper form of bridge security, like a multisig, maybe like a 2 out of 2 multisig or so. But if the message is very high value, you might want to be more precautious, go through a more expensive security module, such as maybe an optimistic one where you have to wait 7 days, or maybe a stricter multisig, and so on. That was Hyperlane V2. We've very recently released Hyperlane V3, which introduces hooks, which we believe is like the ultimate form of interoperability UX. They allow you to pass messages cross-chain, not only via Hyperlane, but also via any bridge provider out there, be it native rollup bridges or external interoperability protocols. You just select the hook you want to use when a message is dispatched, and the message is routed through that external bridge provider or rollup or Hyperlane security module. A hook is comprised of 2 contracts, one that lives on the origin chain and another one that lives on the destination chain. So in this diagram, here you can see the hook and the hook ISM. These essentially abstract over the interactions of the external bridge provider. So you have the sender that calls the mailbox, and when you call the mailbox, you can specify the hook you want your message to use to be routed via. And then the mailbox will see the hook address and will call it with the message. It's able to call this hook because it implements the iPost dispatch hook. The hook will then call into the external bridge provider smart contract. You'll have the infrastructure of that bridge provider pass your message to the destination chain. And ultimately, the message will reach this hook ISM, which is the destination of the message when it's passed through the external provider. Then the final step is for the relayer to call the mailbox with the ID of that message. Mailbox will call the hook ISM to verify whether that message ID was received, and then it's forwarded to the recipient if it was indeed received. To give you an example of a hook we already implemented, it's the OP stack hook. The diagram looks exactly the same, and what it does is we have this OP stack hook on the origin chain that abstracts away over interactions with the L1 cross-domain messenger of the OP stack, and then the OP stack ISM, which acts as a receiver from the L2 cross-domain messenger. Say you wanted to use a new bridge provider that's not currently supported by Hyperlane, you can do that yourself. It's fairly straightforward. With the Chainlink CCIP example, you just need to abstract away over sending a message and receiving a message, and then the entire Hyperlane infrastructure will manage delivery for you. What this allows you to do, and I think is really cool, is it allows you to aggregate several bridge providers or security modules that you configure via Hyperlane. So for instance, you can say, only deliver my message once both provider A and B bridged it. This greatly improves resilience because if provider A is hacked, the message won't get delivered because you need both of them to deliver your message. Or you may want just to have a provider A and a multisig that maybe mainly your team controls. The bridge is still not centralized because you rely on both of them. But like if provider A is hacked, then your entire bridge isn't hacked. One implementation detail, if you do decide to implement a hook of your own, is that the mailbox makes two calls to the hook contract. One is to quote, this quote dispatch call that reads the fees that the sender needs to pay. So your hook has to call into the sending contract of the bridge provider, read the estimate fee, return it to the mailbox so it can charge it from the user. And then the mailbox will call post dispatch, which is this interface call, with which the hook will then call into the, in this example, CCIP send smart contract. One of the main bounties we have in this hackathon is to build on hooks. So my question to you is, what will you hook? That was the first part of the workshop, modular security. Now the second part is permissionless interoperability. So the ability to deploy Hyperlane everywhere. We'll cover permissionlessly deploying Hyperlane with our new CLI, spawning off-chain agent infrastructure with essentially one click with Kurtosis Cloud. Shout out to the Kurtosis team here. They worked really hard to make this happen. And then sending a cross-chain message. And you can have this entire infrastructure spun up in less than 10 minutes. Because internet tends to be unreliable, I already have a recording of this entire flow, so I'll just walk you through it. We have docs in place, but I'll just explain the, let's see, the flow to you. So the first command we're using is called Hyperlane config create chain. Say you've just run a new rollup, like it's a rollup you own and you want to have it supported by the Hyperlane network. The first command you'd run is Hyperlane config create chain to create artifacts for this rollup or new chain that you want to support using Hyperlane. And these are really the details you'd use to fill in MetaMask. So it's a name, a chain ID, and domain ID, which usually match. The protocol type in this example is Ethereum, because we're bridging to Ancient 8. Hyperlane currently supports Ethereum, Solana, and Cosmosm. And the provider RPC is, again, what you'd be pasting into MetaMask. So this outputs one artifact for you called chains.yaml. Now, say we want to use a security module. Just for the basis of this demo, let's use a 1 out of 1 multisig. And the command you run for that is Hyperlane config create multisig. It asks you, okay, which chain do you want to create this multisig for? We're going to say Ancient 8 test, the one we just created. So the CLI reads from the artifacts you just created. The most basic form is message ID multisig. Threshold will be 1 in this case, because we're going to run a single validator of chain agent, which signs messages. And we're just pasting the account here, and now we have another artifact. With these two artifacts, we can now deploy Hyperlane. So the command is Hyperlane deploy core. I'm just passing a private key in the environment to be able to pay for gas. We're going to be prompted for a few details, like which chains do you want to deploy Hyperlane between. We're going to deploy between Ancient 8 test and Gurley in this example. So I'm going to select this and that. And then let's see if there's any other questions. Existing contract addresses relates to existing artifacts, but we don't have those, so we're just going to say no. And select the security ISM you want to use, which is the multisig we just set up. Is this deployment correct? Yes. And now, a whole range of contract deployments starts. It takes about maybe 5 minutes on hotel Wi-Fi, which happened this morning. So I'm just going to skip over this. There's quite a few deployed contracts. So, between Gurley and Ancient 8. Once this succeeds, you get 2 more artifacts. One is for the core deployment. That's the address of the contracts that were just deployed. And another one is the agent config to spin up your relayer and validator. The relayer is used, again, to pass messages between chains, and the validator is used to sign messages as part of the multisig. With these 2 pieces, the artifacts, we can now use a Kurtosis agents command as part of the Hyperlane CLI. So that's Hyperlane deploy kurtosis agents with a few command line arguments, like origin chain is ancient ETH test. For the validator, we're passing the path to the artifacts we just got from the deployment. And the relay chains field here relates to the chains the relay basically connects. I think my first attempt here was unsuccessful because I passed the wrong path. Let me fast forward. Boom. And basically this CLI command outputs a URL. I'm going to take this URL, copy paste it in my browser, and with one click, I'll be able to deploy the relayer and validator in the cloud without me having to do any sort of complicated setup. The only thing I need to add is the private key for the validator and relayer. So I get a pre-filled in form with all the details for the deployment. I'm just going to copy paste the private key that I used when I signed up the validator earlier in the security module step. I just click run, and a lot of magic happens in the background. So like some Docker images I'll pulled in. I guess some cloud instances are created. And now I have this environment called random name Murky Meadow, a validator, and the relayer. If you click on the relayer, you can see its command line logs. It's currently scanning for events on both mailboxes, on both chains. And the validator as well is scanning for messages on ancient ETH to sign, potentially. So the last step of all of this is we now have a live Hyperlane bridge between Goerli and ancient ETH, right? So now we can use another command, Hyperlane send message, to send the message between Goerli and ancient ETH with the new bridge infrastructure we've just spun up. Again, I'm passing a private key in the environment to pay for gas. And I just do Hyperlane send message from origin Goerli to destination ancient ETH test. And I need to pass the artifacts from my prior deployment on ancient ETH. Let's do that. And now the message is dispatched. We're just waiting for inclusion in the blockchain. We're going to get a message ID, which the relayer will be scanning for. Let's fast forward a bit. That's the message ID right there. This is me just looking through the logs. In the end, I decide, let me just Control F this message ID in the logs. I wait for a bit, and then I find a log from the relayer saying, okay, found this message on Goerli. I'm going to dispatch it to the destination you just told me to. This is the message ID that I'm sending. And then within a few seconds, if I go back to my CLI, I'm going to be able to see that the message was successfully delivered from Goerli to ancient ETH with a deployment I just created in less than 10 minutes, really. Yeah, so that's my workshop. Let's see. As to bounties for this hackathon, we have 4 bounties. I invite you all to check them out on the ETHGlobal website. Yeah, and happy to take any questions after this. Thanks so much. Woo. Yeah.
We only need to have a relayer if we deploy Hyperlane between 2 chains where there is no connection already, right?
Exactly.
Otherwise, there is like a
Exactly. So we can use the CLI to send messages between existing deployments. We also, in our docs, you can see a way to directly call a mailbox on an existing deployment with cast, Foundry's cast, and it's very easy. Like it's literally a single command. It's very easy.
Okay. Okay. Thank you.
Yeah.
With the hooks, I didn't get why with the hooks there's still like a relayer involved. So the whole other flow on the right is just like an extra step to do like before the actual message, but then for the message you still need like the same exact logic, right?
Yeah. So the reason for that is that the hook has 2 parts, one on the origin, one on the destination, and basically the message from the external bridge provider gets sent to the receiving ISM as part of the hook, right? So say you want to aggregate 3 external bridge providers, you're going to have 3 receiving ISMs you need another ISM to aggregate those three. So you need the relayer to ping that receiving ISM that will query into those three receiving ISMs from the external bridge providers to then mark a message as valid and finally deliver it.
What do you mean with ISM? Maybe I missed it.
Say again?
ISM?
Interchain security module.
Okay, yeah.
It's the contract that validates a message at the point of delivery.
Okay.
So if we didn't have the Hyperlane relayer, you wouldn't be able to aggregate multiple bridge providers.
Okay, I see.
Right? Because, yeah, you can't just send all three messages to the recipient and then expect the recipient to implement validation logic. You need an aggregation.
So let me see if I understood. So for example, with a hook, I can do something like, I want to send a message to this destination chain, but before executing the message, I want to also bridge funds to that chain. And once the bridge is done, I complete the message, something like this?
Let me go back to this. So in this example, say you have two more external bridge providers.
Mm-hmm.
Each bridge provider has its hook and hook ISM, and you'd have three instances. And then you have another hook ISM, which kind of aggregates those existing three hook ISMs. The relayer will call the mailbox, and the mailbox will call the aggregation hook, which you'll then call into its constituent hook ISMs to check if a message was delivered. So this has nothing to do with funds, like Hyperlane.
No, yeah, that was just an example to ask if that's something that is possible.
So basically if you want to bridge coins and you want to have this redundancy with three providers, you would wait for the coins to be delivered 3 times to then only consider the coins delivered once. Right?
Yeah.
Like you have that redundancy.
Yeah. Okay. Yeah. No. Okay. Yeah.
Yeah.
No,
Thanks
that's
so
okay.
much.
That's okay.
Let's chat outside. Okay, good.
Now my presentation is here. Hey guys. So today I want to talk to you guys about Cessia and how we can have 1 billion CPU cycles per transaction. And what does it even mean, right? Like how can this be possible? And why is it useful for us? I want to make also like a statement of why we need content scalability and how this is possible through the usage of what we had before for so many years in software industry, the development of the software industry. So the agenda for the presentation today, I'm going to go quickly over what is Cortezi. I'm going to give a quick intro to Cortezi rollups, a little bit of how the architecture looks like, the external interfaces you're going to be integrating with if you're using Cortezi, and what is the role of Linux there. And finally, I'm going to show a little bit of what other projects have done with Cortezi, just to showcase a little bit of what's possible. So to begin, as a quick sneak peek of a simple smart contract using Python. I know it's a little bit too much right now to just grasp at once, but I just want you guys to have an idea of what's going to make sense pretty soon. Basically, here we have a Echo Python application, meaning whatever you send to it, it replies back. Nothing too much. The idea is just to show the usage of the API. And to your side, it is a Python application. And you see you're just using basic libraries. You're just doing basic post requests. And that is all you need to create a smart contract right now. OK, moving on to Cortezi. So we have the great trilemma that everybody's so used to by now, I guess. And that's why we're having layer 2s. Ethereum was great to give us compatibility over with a lot of security and decentralization, but we are lacking so much on the scalability point of view. And rollup brings a new narrative, the narrative of using Ethereum as a judge, not as the world computer anymore, not as much. And Cortezi moves it forward asking, what if we can have the great security guarantees and decentralization of Ethereum, but with great tooling and bringing back the complex computations that we are used to have in the Web 2 world? And to have that, we have a two-part solution. Some people are already used to this. You have application-specific in one side of it, meaning you have your own little network per dApp. So for people who are not familiar, Ethereum is a general network, meaning every application is sharing the resources of the network. And many rollups go that way as well. But you can do a rollup per dApp, meaning you won't have the resources limitations. You won't be sharing these resources among all the applications that want to interact with each other. And that is good, because it gives us freedom to do the second part of the solution, which is not to reuse the EVM execution environment for the newer applications. Instead, to use what we are used to have. Like in this case, we are using RISC-V. Think of it as an open source for processors. So it is an instruction set that is as complete as Intel, AMD. You can run an OS on top of it. And we are running Linux, of course. So what this solution comes, when these two things come together, basically what you have is a Linux server as a rollup, in a way. And this is what it looks like. You go back to understanding and really like seeing how EVM tooling is just like playing with pliers, trying to do every kind of task. You can accomplish much using the plier, but it is not the best way to resolve all kinds of issues. And when you use Cortezi, you go back to having the full tool set. You have all the IDEs, debuggers, security tools developed for so long, all the other libraries and frameworks, and you don't need to be reconstructing everything that other developers have been building and distributing for free for so long. And to build a dApp on Cortezi really is to just do a Docker build. So you have the emulator of Cortezi already being baked into one of the images, and you're using RISC-V as the base. Whatever you produce as binary here can be assembled together with the Cortezi machine, and you can run that. It's just that simple. So what happens is you feel like Ethereum is not looking towards solidity as much anymore. We've been seeing other projects looking to WebAssembly, looking towards having other languages as well, because everybody's starting to understand we also need content scalability. We need to be able to express more, coding less. And if you have an OS, you couldn't be more close to it than by using an OS, because now you can really reuse all the tools and libraries, frameworks, again, that has been built for so long for the Web2 ecosystem. So in order to have somewhat of a comparison and to make sense of this, we are going to take one Ethereum block. And at most, and we're going to be very generous with Ethereum here, you can have 30 million gas on a single block, paying extra for that, but you can have it. And the least expensive but still useful opcode is add. You cannot have a full transaction with add instructions, but if you could, you would have 10 million instructions being executed in a single block. Okay, what does it take to boot Linux? To boot Linux, with much more complex instructions, you need 36 million CPU cycles. So you're never really booting or verifying Linux on chain. And people might even ask, what's the point, right? But besides the point is, how does it hinder us from doing extra interesting things if this is not even on the picture? And by using the block as a comparison, we can say the block is on average 13 seconds. And on a laptop such as the one I'm using right now, you can run 3 billion CPU cycles, 3.7 CPU cycles of the Cortese machine emulator. So this is a very difficult kind of comparison to make just by hearing these numbers. So here's a graph for you guys. The black dot over there is how many CPU cycles you can have on a single block on Ethereum. And the full square is the computation size of 13 seconds on this emulator. So it really gives you so much more when you can start rethinking how to build the apps as application specific. And also, it gives you much more because you can just import the work of the whole community instead of replaying things all over again. So the architecture, how is the Cortese rollups itself? It's not that different from other rollups and the architecture of the Web3 ecosystem. So you have basically, let me see if I can, yeah. You have basically here a browser. You're going to still have your JSON RPC connection, be it with Ethereum chain or some other layer 2, if you're deploying on top of them. And these are for the input, so data availability. You're going to have some Cortese framework, rollups framework here as a node. And what you're building really is just the heart of it. Here I'm calling like a CM, the Cortese machine. And to facilitate this, we already baked in a rollup API inside. So to integrate your contract, to integrate your code, basically you're doing a REST API calls. It's nothing much more than that. And to query things, to execute upon them, you can have two APIs here. You have a REST API for ephemeral requests. Think of it as Ethereum call or static call. So from the outside, you can execute the machine and inspect its state. And you have a graphical API to query all three types of outputs the machine creates that can be actionable on the base layer later. So going back to the code, right? Yes, go ahead.
Can we call the blockchain directly from Cortese if you go to the previous slide?
Oh, yes. It will be an async call. You still need to go through the window of dispute window. Yeah.
So can I write something on a contract from the Cortese rollup?
Yeah. What is? Yes. You should. Sorry?
Can I mint a token?
Yes, you can. You can. Let's say, because the Cortese rollup is still going to be represented on the chain as a contract itself, right? So it can execute anything as any other contract on the base layer would.
So if I want to mint an NFT, for example, what should I?
You have two ways. Let's say you already have a token factory somewhere, or your ERC21 is already out there, and you're just calling the mint function, then it's just that transaction, right? That after settlement can be executed. Or you can deploy a whole new contract as well.
And the
these are all layer 1 things. When you go back to the context of these layer 2, this application specific, it's up to the implementation of the application itself. So there is no concept for gas here, not directly. Make sense? So for instance, you're still going to be paying gas as layer 1 inputs, just for the data. But you're not going to be paying for the execution itself.
Maybe like if I'm in the courtesy machine, so I need to run, can I run hard within it and then make some calls to...
Oh, you can. But then...
Put a private key inside.
You shouldn't put a private key there, because then this is transparent, right? This is a framework here. So everybody who is participating on the dApp basically should ideally be running their node as well, not just trusting a third party. By then, everybody has access to that private key as well. So it's really like there is a contract here on the base layer. Let me see if I can, yeah. On the base layer that represents the whole rollup, the consensus and everything. And from this contract, it can execute transactions from that address. That's going to be the alias of it. And then by the consensus, it can create any kind of transaction. So through the computation, if the computation, it can be a Python code saying, do send some ether to somebody. That thing is going to go through settlement, and eventually it's actionable. You can call on the contract saying, hey, I have here, we call it vouchers. I have here a voucher. I want to claim the voucher, so it becomes a transaction.
It's like you prepare the transaction and then someone needs to sign it.
No. Yeah, from the external side, yes, somebody's still signing it. Other people might think of it like as the sequencer or as the validator node always doing the checkpoint. It might be just the user. If it is a game, they want to take their money out. It might be the user, they get the voucher and sign the transaction out. But it still needs to be validated by the consensus, right? Yeah, we have macro proofs of the validity of the voucher. So onto the code, you're going to see something similar to that. On the left side, we have a mini curl that we created to facilitate things. Think of it as an MVU cast, the Forge cast, I mean. And we are sending a payload hello, and we are getting a new notice. And notices are just Ethereum events that are provable. Different from the Ethereum events that you cannot really prove anything about them. People just know they are true because they are running the node themselves. These notices, they come with a Merkle proof. Okay, and on your right side, you have the code. Fast forwarding, because we use it some of the time for the questions. What you're gonna see is like we have two main states of execution of the contract, of the machine itself. We are telling you through the framework in which state you are. If you are receiving a request in an inspect state, it means you're gonna be reverting back. You cannot change the state. It's like a Ethereum call. You can mess with the storage, it's not gonna be there. It's gonna be rolled back. And there is the advanced state. Because this is an input, it's gonna be executed as advanced state. So you enroll the request JSON body, you inspect the thing, you see that it is a request type of advanced state. You go to the handler, so at the top level handler, you can implement as many as you wish. It really feels like an API. And then you're gonna go to the function over there, line 6. There at line 7, we are getting the payload we just received and copy into a new notice that's gonna be created. And finally, we hit the endpoint notice. And just by hitting this endpoint, it's gonna be creating this event I was talking about. And you don't need to do anything else. You just see that the response was 200, just like any REST API. If it is 200, you return accept. And here's one of the nicest features of the framework. Because you're dealing with this API, if you were to call line 24, finish, without being accept status, it means you're throwing. It's like you're reverting your whole transaction just like you would on EVM. So that gives you an easy way from any kind of language to control the state of the machine. Are you progressing? Was anything wrong with this input and you can't process it? So you always have a good state of the machine going forward. But it was as simple as just integrating with the REST API instead of having to learn all the languages. Oh, 2 minutes, guys. So to go over, you can further decentralize your dApps, express a more complex logic without making your code more complex. It's easier in the future when you have a successful project to even board new developers from the Web2 ecosystem because they're going to know the language already. About the POCs, really quickly, I'd love to talk much more about them, but ETH Lisbon, this lady wanted to do a verifiable chat GPT, and she ported a Stanford Alpaca model inside the Cortese machine, and she proved that you can have verifiable prompts and the outputs running this on the Cortese machine. And the second guy, he created a system. It was a proof of concept to have biometrics check in and check out, for instance, like as in a workplace. And what he does here, there's two things that are interesting. First one is he uses OpenCV, a very common framework for computer vision. He just needed to import it, and he can verify that that's the fingerprint of a person, a specific person. And also he used a machine learning model that he trained to test whether or not the fingerprint was spoofed. You can check much more at this rollup lab site. There's many projects that have been built for Cortese so far. At here, we are going to have like 10,000 prize pool. First place, 5,000. Oh, typo there, guys. Oh, that was the idea, so I'm sorry. 5,000 prize pool. And there was a few more things I wanted to discuss with you, but I guess I can't, so I don't have much time anymore. I wish to see you guys out there. I'm going to be at the table or the recharge station there. You should get a massage there, guys. It's really good. Thank you. Thank you, thank you.
Two minutes. Okay, so let's start. Can you maybe close the door a little bit? It's quite noisy. So hello, thanks for coming. My name is Mikhail and I'm original inventor of Gearbox. And today's speech we will talk a little bit how many interesting things you can build on Gearbox, and we choose a very narrow topic which is called bots. I believe it's quite interesting. To introduce me, I am a hacker like you, so I participated in many hackathons, primarily for crypto. And as you know, Gearbox was created during ETHGlobal Market Make Hackathon in 2021. And after the demo day, thanks for Kartik, thanks for all support of ETHGlobal, it became a real project. And now we deploy it on mainnet since 2021. The highest CVL we achieved was around 120 million. Now it's around 30. And pretty soon we will deliver V3. So I consider hackathon is the best way for innovation to create new ideas, test your hypothesis. And today my short and brief discussion about our bots, what to inspire, and show how many interesting things we can build together using Gearbox bot concept and how it could be done practically. So I will try for next 20 minutes tell you how to build something interesting in 2 days. I know how it's hard. As I said, I'm already hacker. I know that time is going too fast and you should implement smart contracts, front-end application, and so on in a very short period of time. How to get as many integrations as you can because there are many interesting protocols as well. And of course, people want to learn more from different protocols, get more prizes, and make something which could really be helpful for community and different DeFi protocols, and of course how to set up environment and do some practical stuff. So let's start a short and brief explanation what Gearbox is. Gearbox is a solution which create a on-chain credit or credit abstraction. So basically we create a protocol which I think quite novice, and it represents a credit account abstraction. As you know, account abstraction is the way how you can really manage your on-chain activity using smart contract wallet. And Gearbox could be considered, and credit accounts itself, as a smart contract wallet, but you have 10 times more money on them. So really incredible, like a credit card. You shouldn't worry how to money get in and out. You shouldn't go to Aave for looping and so on. And of course, our primary usage is leverage, but we are open to create many new things. So as you can see, you can be EOA, you can really use any wallet account abstraction, you can connect our credit account and interact with different protocols in native way. There is nothing to be programmatic before. It's really like your wallet, but of course it has some limitation. And if we go to briefly to architecture, we shouldn't spend a lot of time here. As you can see, Gearbox is two-side protocol. On the left side, you can see LPs, people who are interested in passive income. They provide liquidity to our pools. Our pools is one token pool, so they have no impermanent loss and so on. A little bit similar to Aave, so you can provide USDC to USDC pool or ETH to ETH pool and so on. But what is really exciting is the right part. So in the center, you can see a credit account, and if you a Gearbox user, you can open multiple credit accounts wherever you want, so you can 1, 10, 100, like wallets in your MetaMask. And then you can send transactions. And when you open this credit account, or even after, you can provide initial funds to be able to get a margin loan. For example, let's check how it works. Oh, it's transaction, sorry. You provide 10 ETH to credit account, and you take leverage or margin loan from the pool like a 90 ETH. After opening credit account, you have 10 times more. And then you just send transaction to credit account. They automatically execute it on third-party protocol in a native way, but all tokens and outcomes should be on this credit account. And here, a more detailed version. So you can see as account owner, you send a transaction or a batch of transaction. Then they will be checked because the target contract should be whitelisted. From the risk perspective, it's significant not to send money everywhere. Then we check the token you will get back is in collateral list. So we should really have some experience how to evaluate these tokens. And then the transaction or batch will be executed. And after that, we will compute health factor just to be ensured that there is enough money to pay the debt back. Is it clear or any questions at this point, guys? Okay, let's move forward. And the problem we really want to solve using bots, that probably users should continuously check their health factor. They really want to go to vacation and, for example, forgot about some debt and so on, because as you know, crypto is a high volatile market and you could not predict what could be even the next day. So we try to find a way how to solve the interesting problem of, at first part, automation of everyday leverage activity. Another part, what we really want to do is to be able to connect different servers to manage your portfolio. As you know, if you want to build a bot in Python, in TypeScript or Rust, you should provide a private key. It's not safe when you will keep it in plain form on your web server because someone could crack your server, take the key and steal the whole money. So we want to solve this problem as well. And of course, we want to create a lot of possibility like an ecosystem, like an app store for unleashing creativity and create a lot of different stuff. And here how bot works. So just to remind, here a credit account simply works as a smart contract wallet. But now, not only you can send transaction, you can allow external smart contracts to do it on behalf of you. It's a quite simple idea. However, we have a very robust permission system, so you can allow some bot just to add collateral. It makes sense because if your health factor is going down, you only need to implement one function. Just give me a collateral somehow, yeah? Or you can build a bot, for example, which could really swap one asset into another, and it could be done like add collateral and withdraw. So basically the idea is a very simple, it's doable during the hackathon. What you should done is the way how to automatically provide transaction on behalf of account owner and how to build a trust model, because of course owners could be worrying about allow some bot which do not check and meet some security measurements. So, oops. There are a lot of ideas which we can implement. So the first part, of course, it's AI agents, portfolio management, and different stuff. You can use ChatGPT, you can go to Hugging Face and find pre-trained model, wherever you want, because now you have the way how you can really automatically execute any prediction. With bots, we can connect to really a lot of interesting stuff which could be computed off-chain, because it's quite difficult to build neural network or using smart contracts, but here you can build some part off-chain and then allow to be executed by bot. I think it's a really interesting and good stuff to development. Of course, great UX. It's amazing. You can connect your credit account with Telegram, with Lens, wherever you want. Because, as I said, you should not keep your private key. You can set permissions. You can really provide a lower possibility to manage your fund. You can say, hey, my Telegram bot could be racked me more than 10% in months. And even in the worst case, you will still have your money. So it's incredible. You can build different things related to health factor protection, comparing with Pash protocol. So you can say, guys, hey, you have, for example, credit account going to be liquidated soon, a few notification, but if a user in vacation and forgot ledger somehow, you can do it for himself and take some profits. Also good. And of course, a lot of stuff to be integrated. Cow swap, 1 inch, any protocol. For example, you can build a limit order bot using Flashbot together. So I think it's also pretty cool stuff, because using cow swap, you can find better rates. You can really execute limit orders and create totally new experience for credit account users. So a lot of interesting stuff could be built, and let's check how it works. In practically, because we are developers and on hackathon we should deliver some code. Let's check how it works step by step. Let's start from the bot anatomy. So at the first part, you should create any function which could be executed. And here 2 possible types of bots. Some of them could be private. For example, you're a hedge fund and you want to create some proprietary wealth management system which will be closed and used inside your organization. You can create some access modifiers like owner only, then bot you connect to your system is fully private, it's totally okay, and then you can maybe stream some AI data or some risk data to the bot and understand how to manage the funds. Or maybe what is more interesting, you can build a public bot and it has no access modifiers, so everybody could call it, everybody could connect it to its own account, and then of course these execute methods could be triggered by you if you have some server, or you can ask any automation platform like Gelato, for example. Then we should build inside a trust model. Gearbox bots has a very and incredible open API, so we have some things to measure and help you to measure. For example, you can store some balances to prove the user that you do not take more. You can really set the minimum level of health factor after the execution and so on, but the primarily efforts to build the trust is on you. So because for example, if you make a swap from one token to another and you want to say, hey user, we will never pick a swap than 5% worse than Chainlink. It's an idea. So you, in the trust model block, when you can see a function called store state, just get a Chainlink price, you compare this price with tokens, and then you can check it after multi-call execution to prove that everything is okay. If the price was not so good, for example, you have a strong price impact on Uniswap, you will revert. Pretty simple, build a good trust model, and users who you provide this public bot will really happy. And the centerpiece is a multi-call, so Gearbox allow you to really combine transaction in the batches. It's quite cool, so you should not really do continue things, approve, call Uniswap, approve, cold curve, and so on. Just list what you need. If you want to call Uniswap, and Gearbox itself will provide needed allowances, approvals, and take them back after the transaction. If you want to build more complex stuff related to adding collateral and so on, everything, the whole account management could be also done in the same multi-call. Any questions at this part? Everybody knows how to build. Okay, perfect. And there are three corner things. I believe maybe I could not go more details, but what we can deliver today for you. We have a public testnet. It's Anvil fork for everyone. If you want to have your own personal public Anvil fork with deployed V3, just ask our team on a stand, or we will provide any different things like Telegram channel, Discord channel, and we will provide an URL for you which represents RPC. We have a pretty fast RES Anvil which could really help you to test your solution much better than you will really use Infra, for example, or Alchemy. Each such deployment lives 24 hours, keep this in mind. Multi-call, what I mentioned, amazing tool to put all transactions together to be executed at once. And another part we can also provide, keep in mind, a router IP. A router could help you to find the best path between two assets. So if you have no idea how to build multi-call, it could be a little bit more complex during this today's on hackathon. Just ask router and say, hey, router, help me. I want to swap USDC into this convex position, what to do? And you will get multi-call immediately. Very cool. So basically, do not spend time on small things things wider and create a great picture. So we have all those tools together, just ask for them. And now let's check what I already promised as a code, and I will show that, oh, I think it's, should be, yeah. And prove that writing bots, it's a very fun thing. So basically here, we will, it's not account manager, I think, limit order bot, what we already mentioned before. It's quite easy to build. So of course, the first part, you should clone our repository as it written in docs. Just git clone, force install, and everything you need in the repo of the smart contract deployment. No more complex installation. Then you can start from this like a boilerplate and create wherever you want. So nothing to go deeply to libraries and find different stuff. So here you can see a very, very simple things just to explain the limit order bot. So we have an order, and here you can see borrower is an account owner, manager is a credit manager, and this is a contract which allow you to really get and execute different stuff. Credit account is address of credit account. Token in, this token you want to really go out from account, token out what you want to get. And I think all other things are pretty understandable here. It looks like a Uniswap transaction struct or similar to it. So you create a simple contract. Let's keep orders one by one in a mapping. And to store the latest ID, let's add an internal variable called next order ID. A few events just to be able to manage what's going on with your contract, and of course for monitoring as well. And here some errors to understand what was incorrect. But here, as I said, 3 functions to show how it works. The first part is the part when you can submit order. It's a pretty simple. We just store it in a mapping and increase the index of order ID and emit events. The second part, we just want to cancel order, and we cancel it here. And the latest part is execute order. So maybe it's the most interesting part of our bot. So everybody could call execute order. So it's why limit orders could be called by any gelato person or any other stuff. And of course here we do not focus on how to pay rewards, but of course it's up to you how you are going to pay this. And you can see it's quite simple. The first we validate and get amount int and main amount. Then we transfer funds from MSG sender to the bot account, because bot will be a counterparty in this multi-call, and create approval to the manager. And then it's quite easy. We create multi-call of 2 positions. The first one is add okay, sorry. Yeah, sorry. I hope this is all code, so you can find in our repos. Thanks for attention and your time, and let's build together. No problem. Yeah, sure.
I'm Yujang, and I am an engineer here at Axiom, and today is the workshop. So let's get started. So what is Axiom? Well, Axiom essentially enables ZK superpowers for your smart contract. And what exactly does that mean, right? I'm sure you're wondering. Well, let's just back up a little bit. So right now, smart contracts really only know the current state of the blockchain. they can only see things like, let's say you go to Etherscan, right? And you look at some random account. You can only see like the current balance of that account on chain and like, things like how many transactions that account has sent via the nonce. So all this data that's in the red here is actually data that is not available on chain. And what that means is that you can't use that in your smart contract until now, right? So much of this rich on-chain history is just not available. So you can see the number of transactions, but you can't actually see what's in those transactions. So accessing more data on-chain generally just requires trade-offs, right? So you can either pay more to store data in the state of Ethereum because the contracts can't access the history, but that imposes like some extra costs on each user. When you store more state, you increase gas costs, essentially. Or you can reduce security and use trusted oracles. So that also introduces additional trust assumptions on users. And it also lets you scale. It also prevents you to scale in a lot of ways. So developers either have this conundrum, right? They can either increase the cost or decrease the security. So then the question is, how do we enable smart contracts to leverage the rich history of on-chain data? So what Axiom allows you to do is access data with ZK cryptography instead of consensus, right? So if you look here, this is essentially a model of a blockchain, right? So each past block commits to the entire history of the blockchain, and each block has commitments to the state, the transaction, and receipts. And so proving that data in ZK enables scale and composition, because when you prove it in ZK, you're able to basically get all this data and put it and use it in your smart contract. And what we have is this REPL that we have online. It's repl.axiom.xyz. It's basically an interface that allows people to write their own circuit in a JavaScript EDSL that's a wrapper over Halo 2. And so what this means is that you can grab historical data like block headers, accounts, storage, and you can also get data like transactions, receipts, and mappings. And so what we do essentially is we let you specify this application logic in the REPL interface, and then you can export a client-side ZK prover that you can use in your WebD app. So where does Axiom fit in this whole stack, right? So essentially you have the front end, which is like your client app, and then on the back end you have like a data aggregator or indexer. That could be anything like Alchemy, Covalent, QuickNote, et cetera, et cetera. And then between the backend and the blockchain itself sits Axiom. So we have off-chain and on-chain components. And then essentially we will send a callback to the developer's contract, and the developer can then process that data in whatever way they see fit. So I'll just really quickly go over this workflow. But essentially, we start off with generating a compute proof via a client-side prover, right? And then with that proof, we send a query into the Axiom contract. The Axiom contract then generates a proof on the proving server. And then the proving server sends the result of that proof to the Axiom contract, which then calls the on-chain verifier. And so that data is verified before it's sent via a callback to the developer's DApp contract. Yes?
Is it possible to access the proof in the callback?
The actual proof itself? Not right now. Yeah. But that proof data is available, like if you look in, we have a thing called Axiom Explorer, and so that proof data is actually available there. And so we aggregate all this data via universal aggregation. So the compute proof and data proof that is generated on the client side in Axiom REPL, that circuit is put into universal aggregator, and then we are able to verify it using a universal on-chain verifier. So what this essentially means is that there's no ZK-related smart contract deploys that developers need to deploy in order to use Axiom. And so using results from for Axiom in your smart contract is as simple as just adding this very specific function to your contract to receive the callback. And so this is just a toy example that we'll be going over. And it's on governance. So how is governance done today, right? Users will vote on a proposal. If the proposal passes, then we trust some entity or entities to implement that proposal. And sometimes they don't. So what exactly are we building here? We're building a contract and DApp whose parameters are autonomously governed by users who meet specific criteria based on their past on-chain actions. And so, well, let me back up. In this specific case, the past on-chain action that we are looking at is whether a user minted an NFT and are still holding it. So essentially, we have 4 pieces to this, right? We have this first piece, which is the NFT project, useless NFT, which is in ERC-21. We'll pretend it was minted like a year ago or something. And then the ZK circuit with Axiom REPL. So we write a circuit that checks that a user minted this useless NFT. We have the NFT project's new useless governance token that they want to deploy. And this is where the Axiom callback is implemented. And users who've minted the useless NFT and still hold it can influence the token's parameters directly. So basically, each of these users who have minted the NFT and still hold it are able to vote to increase or decrease the token's tax and stake rates by 0.1%. Whether this is something that you actually want to do or not, that's a question for yourselves. But then we have this web DApp front end, right? So users will connect a wallet. An app uses an indexer to find the useless NFT mint event, and then qualified users can vote, and then it generates and sends a query to Axiom. All right, so this is part 1, part 2, part 3, and part 4. All right, so the high-level architecture is as such. So you basically just have this user that mints this useless NFT, and then the developer creates a circuit in Axiom REPL. They have this web app, and then some data that talks to an indexer. Once this query is sent, it's sent to Axiom V2 query, who generates who sends the data to the prover, and then the prover generates the proof, and then it's verified in ZK. It's verified on the on-chain verifier, and then the callback is sent to the useless governance token. Yes?
Is the prover or the V2 query, like on-chain verification, is that open source?
Yes, it is. So actually, right now, it is still, I think, closed source and in development and audit. But once it's all done, that will be open sourced, and we've open sourced Axiom V1 already.
Is kind of like the high-level API the same?
Yeah, no, Axiom V1 and Axiom V2 are completely different. Yeah. Okay, so this is the GitHub to the actual thing that we'll be talking about today. It's axiom-crypto/governance params example, axiom-crypto/governance params example. And we'll have a link to this at the end as well. So first part is this useless NFT, right? So we have, it's just like a standard, completely unremarkable ERC-721. And then we have an external mint function that allows anyone to mint an NFT. I'm not going to go over this at all because it's just very standard. But for Axiom REPL, what we're interested in is this mint event, which is actually a transfer event, right? Where the 0 address is from, and the 2 address is the person who minted the NFT. And then we have the token ID as well, who we're interested in. And then the address of the contract that emitted the event, which is the NFT event, NFT contract. So in Axiom REPL, when you go to the website, there's 2 separate parts. And each part, well, there's one part that's code and one part that's inputs. And so the code is essentially like how you're specifying getting data from the blockchain and then also doing any sort of compute on that data. and it's essentially, you can think of it as your circuit. The inputs is actually what your web app can override or basically like use as inputs to the circuit when you export it. So this mint block and mint TX number will be different for each user, and also the vote value as well. But going over each part, going over each part of this. So we have the transfer event schema, right? So you have the log where you get the receipt, and so for these transactions, there's only one log, and so we know that that's always at index 0. And then we check that the address that's emitted is the NFT contract itself. And then we also want to check that the transaction is a mint transaction, right? So it's from address 0. And then we also want to make sure that the minter's address and the token ID, that we get the minter's address and the token ID. And then we also just want to check that the vote value is either a 1 or a 2, where 1 is yes, 2 is no, and we're not using 0 just to not handle any default issues. And then scrolling down a little bit, then we have these add to callback calls. And so these are the calls, these are what lets you add values to your contract, the callback that will get the data to your contract. And so the data that we're interested in getting is the to address, the token ID, and the vote, which we will handle in our contract later. And so what we're able to do here is export this TypeScript circuit in Axiom REPL. And then also we want to check, grab this query schema. And so the query schema is pretty important. It's basically a commitment to your circuit. And what that means is that when a callback is received to your contract, we want to make sure that that callback is talking about the same circuit that you wrote. And so if you change any part of the circuit, that query schema is going to be different. And so we want to make sure that the callback that you get is for the callback for the circuit that you wrote. Okay, so next part is the ERC20 token, aka the useless governance token that receives the Axiom callback. So it's a standard ERC20 token, and it has state variables that hold the tax rate, the reward rate, and the number of votes, number of voters who voted. And so this has a function to receive and validate the Axiom callback. And for a production contract, obviously you could have like a mapping of structs that holds voting requirements and data for each proposal. But in this case, we are just doing a toy example, and so we just have one contract that has all this data. And so let's go over this part real quick. So here's the Axiom callback query schema that we want to put in here. And this is saved on contract deploy. And then we have the tax rate, reward rate, and total votes, as well as a mapping of people and their token IDs that did vote. And so we have a function that checks if the user voted already. And so we just basically hash the address and the token ID. And then that just returns a true or false. But the main meat of this is this Axiom V2 callback. And so I'm just going to jump over to this other file here called Axiom V2 client. And so this is essentially what our other contract derives from. And so this contract has a function called Axiom V2 callback that has the correct function signature, right? And then essentially we are just overriding these two functions here. So let's go over this again. So in this part, we want to parse the results array, right? So we get a, so if you remember earlier, we had 3 add to callback calls, and so we'll have 3 results in the array. And these results are ZK verified results of your history. So at this point, we parse the results array, right? So we get the NFT holder, the token ID, and the vote value. And then at this point, we want to make sure that the owner of this token ID is still holding it. And then we just want to make sure that we go through all these different validation checks as well. I'm running a little bit low on time, so I'm gonna skip over a few parts here, but essentially we have the vote values that are updated, and then we we have an event that is emitted. And then this is some of the validation stuff. But the next part is this WebD app, and it kind of like has this flow where a user connects wallet, mints, and actually I'll just go over these screenshots real quick here. So we have this page where a user can just mint the NFT, check whether they're eligible, and this is a toy example, so of course they can still just mint the NFT. And then they're able to vote, and then submit this vote, and then once that's updated, then once that vote goes through, then the tax rate and reward rate and the contract itself are updated. And so this is kind of like the whole WebD app flow. And essentially we have something that parses this transaction data, or checks the transaction data from like Alchemy, and then we just make sure that we find the one that we care about. And then these are just things that you can use to build the Axiom query itself. And then, yeah, this is also just building the Axiom query. And then essentially what happens is we get this Etherscan transaction where we see the new tax rate and reward rate that have been updated. So let's talk about the project ideas real quick. So computing the total volume traded by Uniswap pair, providing that a user lost at least 10 ETH by buying and selling an NFT, gating access to a DeFi protocol, trustless settlement of on-chain gas price derivatives, proving that a block contained a sandwich attack, algorithmically adjusting DeFi protocol parameters, proving an off-chain solver ran correctly, giving users incentives or airdrops based on their on-chain actions, minting an NFT or badge for achievements for an on-chain game, or giving incentives for prior users of a competing protocol to switch protocols. And so we have these 5 prizes, and each prize is worth $2,000. And you have best overall use, most collaborative, best use of Axiom for on-chain identity, best use of Axiom for DeFi, and best use of Axiom for on-chain incentivization. So you can build these ideas with Axiom V2 on testnet available today. And these are all the different links that we have here. The example that I went over is in this examples V2 repository here. And then the hackathon guide is at ETHGlobal.axiom.xyz. Thank you very much.
Well, this is not a full house, but I see a lot of good people, so we're going to start. Hi, my name is Alex. I'm the CEO of Chiliz, not from Chile. I'm just going to give a bit of an introduction about who we are, what we do, and why we need you guys to love what we do, because you're going to love it too. Long story short, we started 5.5 years ago a company called Chiliz with a token called CSG and a consumer-facing product called socials.com. And 5 years ago, forget about crypto for us, it was all about the sports industry. It was about the fact that 99% of sports fans are not in the stadium, not in the city, and sometimes not even in the country of the team they are supporting. And 5 years ago, we created the concept of fan tokens. Fan tokens are not NFTs, they are fungibles. They are, I hate that word, cryptocurrencies if you want in that way, but they are crypto assets that are fungible. Some of them actually are listed on Binance and Hobby and OKX and Upbeat and everywhere in the world. And 5 years ago, we started to work with two teams, Paris Saint-Germain and Juventus. Not sure there is a lot of football fan here, but except one at least. Yeah, okay, there is one football fan in the room, 2 football fans, 3 football fans. It's therefore, okay, so that's 50% of the room. But the idea was we created these tokens in order to help teams to engage and monetize their fan base globally. And we've been very lucky. I'm going to fast forward 5 years later. Now we work with more than 100 sports teams. We work with Paris Saint-Germain, Barcelona, Inter Milan, AC Milan, Juventus, Manchester City, Arsenal, Tottenham, Spurs, Universidad de Chile in Chile. We work with the biggest Brazilian team, Flamengo, Palmeiras, etc., etc. Turkey here, which is our biggest market from a user perspective. We have, I think, 500 or 600,000 users here in Turkey. We work with Galatasaray, Trabzonspor, and all the biggest team. And at the beginning, when we started, we had a so-called private chain. It was an Ethereum fork where we minted ERC20 tokens for the fan tokens, but that chain was private, was not at all decentralized, forget it, it's not the point. It was only available, one, to socials.com, which is, and I will talk a little bit about that, which is our mobile app that has 2.2 million users. That is the consumer-facing app for the fans. And then it was, the chain was available, there was a whitelisting VPN-ish stuff for exchanges. So Binance and 25 other more or less exchanges were connected to the chain. So for the first 5 years, 100% of the work of these tokens were done by us, which is cool. We managed to onboard all of these big teams. We work with UFC, Formula One teams. We have the token of Aston Martin, Alfa Romeo. We have we have 80 other brands. But we also realize that first, we cannot do everything ourselves, and that sending all these fans and these users just in our platform is actually limiting the interest of the token themselves. I'll take the example of this gentleman, because now that we are friends forever, we is a fan of a team that we work with, but he doesn't know that that token exists. And it's the fault of the team, it's our fault as well. And we think that what will make a big difference in the next 3 to 5 years is, and we call the strategy fan token everywhere, is how can we help and incentivize and have developers, projects, startups, whatever, developing and building new features for these tokens and for more other things we are launching. You want to show a video, or I have a feeling you want to click on something? Okay. No, but so that's cool. I've never seen that. So going back, let's go back a little bit about what we've built in the last few years, because it's important. The original idea of why we created this concept of fan token, and I'm going to give you a fun fact. The original name of a fan token is a voice token. Actually, the smart contract, I think it's still written vote or voice. Yeah. And we created the voice token because we wanted to give a voice to the fans. You own a token, you can vote on decision of the club. And I'm going to give you some example of that we've done. But then when we started to pitch in 2018, I'm talking like Q1 2018, when we started to pitch about this voice token, people thought, oh, you're launching a new Skype, you're launching a new telecom platform or telecom token. So we moved into the concept and the name of fan tokens. Think fan tokens being a loyalty program that is tokenized. It's literally that. It's Paris Saint-Germain, there is 20 million tokens, they are pre-mined, they are pre-minted. They are right now, I don't know, 6 million, let's say, in the market. And when you own a token in your mobile phone, in this, for now, very centralized app and centralized wallet called socios.com, you can vote on decision of the club. I repeat, if you own a fan token of the team that you like, you can vote on decision of the club. So all the things that you've seen in the rooms there and we've all read about all over the world, DAO kind of things, it's this, but in real life. We are not saying it's a DAO, it's not decentralized fully, but it's a real utility where you as a fan, anywhere in the world, and I'll give this example, I'm gonna take one example that I like. Juventus, so the Italian football team, they were the first one to launch actually the token. So November 2019, so it's that old, well, actually 4 years today, we launched the Juventus token, and fans were able to vote, actually not fans, fan token holders were able to vote to decide what music in the stadium do you want to have when we score a goal. Maybe it sounds gimmicky for some of you, but when you go in the stadium and there is a goal, the music that is played till now was never chosen by the fans. From now on, at Juventus and many other clubs we are working with, this has been chosen by the fans and on-chain. And the fun fact is, so the vote started in November 2019. The result of the vote on-chain was showed to the public in the stadium the 4th or 6th of January 2020. And at that time, Cristiano Ronaldo, was playing for Juventus. We need to thank him 4 years later because that day he scored 3 goals. It ended up being 4-0. So 4 times that day in the stadium, they played the new music that was actually chosen by the fan token holders on the blockchain. And here we are, 4 years later. If you go in the stadium right now, you will hear the music that was chosen 4 years before. And as another fun fact, if you play FIFA or Pro Evolution Soccer, which both probably don't even name FIFA anymore, or Pro Evolution Soccer, that's how old I am, you can hear the music, that music that was chosen because when they try to fit, when they try to be as realistic as the team, they actually buy the right to the music. So the music that is chosen by the fan is actually already in the video games as well. So a fan token, fungible, ERC20, Solidity, blah, blah, blah. I'm not a tech guy here, so don't blame me. But it's purely a utility token where you own it. You can vote. The more you own, the more power you have in the vote, but there is of course a limit because we don't want a billionaire buying all the tokens and say, hey, I'm the only one to vote. And when we started that in 2019, since we've had hundreds, probably thousands, but let's say hundreds of votes, like for example here in Turkey, there is a team, I believe Trabzonspor and Galatasaray, who ask their fan, what number do you want to have on the jersey of the new player we signed? I mean, that sounds silly, but it's super powerful. We had 19,000 registration that day when we announced it, and that kind of thing. So we're doing that all the time. We as a company, Socios, and the Chiliz Labs, which is the, let's say, sister company, that's our job. Now we moved into, okay, we've done that for 5 years, but that's not enough. We need more utility. We cannot develop everything ourselves. We need more flexibility. We need more creativity. And so we opened the chain. The chain became a permissionless chain, actually a few weeks ago. It's a BSC fork, so it's just an EVM. We just like super standard. I like to say, and that's what I will say tonight in the ceremony, is we are not the fastest chain. We are not the best chain. We don't compete to change the world. We don't want to change DeFi, etc. That's not our journey. Our journey is focusing on sports and entertainment, music, TV, and stuff. But let's say sports today, and creating an ecosystem where actually a fan of Barcelona. He's also a bit of a fan of PSG because there was Neymar. He's also a fan a bit of UFC because of whatever reason, and also a fan of Formula One because of another reason. So we know that statistically, sports fans are not anymore fans of one sport and one team. They're fans of multiple sports and multiple teams. We spent the last 5 years signing all of these IP brands, all of these communities. We were the only company building tools for that. Now we grew that space and we opened the chain to allow you guys to try to hack or to develop or to grow other ideas that we have, other ideas that you have. But for the first time ever, you have a chance to work with big, powerful, massive brands where we're going to try to bring users to whatever you're going to develop. We're going to bring the biggest IP or brands in the world to whatever you guys are going to develop. And that's more or less what we were pushing. Let me think if there is something else you want me to talk about there, or if I knew what, yeah. So we do two things, or at least for now, that's how we see it. We have, as I said, the fan tokens, which are these fungible tokens. They are not NFTs, and by the way, we have in the company, but I have especially a love-hate relationship with NFTs. I love the tech, I hate the products. I think till now nobody really scored the right product that makes sense from a product perspective. Very often we are asked, hey, why we don't do your fan tokens but as NFTs? Why? I mean, our fan tokens are just to understand from a liquidity perspective, because it does matter. Fan tokens are traded 4 times more than NFTs today. Let's say depends of the day, obviously. Today is I just checked now, it's 2 times more. The whole NFT market today was traded $42 million. And when I mean $42 million, it includes Bored Apes and all of this stuff that are like premium products. The sports one is probably $2 million, which is like Sorare plus DraftKings and a few other stuff. Fan tokens today was $80+ million. Sometimes it goes to $200 million. Why? Sure, because it's listed on Binance, on Upbit in Korea, on Mercado Bitcoin in Brazil, Paribu here in Turkey. So we are comparing apple and oranges. Don't take me wrong. We cannot compare NFT trading and fungible tokens trading. But my point is, we all know that liquidity matters for whatever all of us are developing. Liquidity does matter. And therefore, fan tokens are a much bigger market to tap in from a liquidity perspective. We have DEXs that's going to come soon. For the first time, we still don't have yet a DEX for the chain. It's coming in a few weeks. So we spent the last year-ish really launching, or preparing rather, the launch of the chain. A few weeks ago, 2 weeks ago, we announced all the first kind of few partners, integration with the WalletConnect and Magic Link and all the stuff that really help everybody to build their stuff, the Biconomy or Biconomy, I'm not sure to pronounce it, for account abstraction. We have all of the kind of pieces that step by step make sense. We have the IP, the brands. We have users, decent amount, but now we need more cool stuff being developed, not by us. And that's on you. And we have these 2 categories, and that's how we also set up the rewards for the hackathon this weekend. There is a category of fan tokens, and there is a category of sports fi. If you have a slide somewhere, or I have it here, because I did my homework almost. There is this, and then there is the other things I'm going to say, or except Max, if you want to jump in on that. But just for you to understand what we are seeing on the fan token and SportFi is, fan token is all about the existing teams we have, these 80/100 teams we are working with all over the world. And by the way, this is a global play, meaning that we have teams in Chile, in Brazil, in Mexico, in Turkey, in Malaysia, in Indonesia, for example, we have the 3 biggest Indonesian team, massive market there, but we don't have yet the perfect tools to be different. In terms of what we are trying to develop, there is fan token gated platforms. My dream is always the same, is I own a Paris Saint-Germain token, I go to a Nike shop anywhere in the world and I get a 10% discount because there was a QR code that allow me to be identified and authenticated to the e-commerce platform I have in front of me. The problem is in every country, more or less, it's different. So it's not a deal you need to do with Nike Global. It's a deal you need to do per country with the general manager of the marketing department, whatever. So we need to develop tools that allows us and allows fans and allows teams to actually scale the utility of these tokens. Proof of attendance is a good example as well. Even though, as I said at the beginning, our main target is actually not the people who goes in a stadium. You know, in a stadium, just for you to know, in a stadium there is usually, let's say, 50,000 people. I don't know in Galatasaray how many is it? 62 probably. Yeah. But they play 20 times a year. A stadium is actually used 20 times a year. So it's not something you can use every day. Having said so, you can create tools where there is a tablet and there is a QR code regenerating every second, and you go there and you scan it, and then you will be identified as a POAP because you are a holder of the team, of the tokens, of the stadium you are. There is plenty of small things like this. There is, of course, some gaming-related experiences. We are looking at ticketing, obviously. Sports data, Oracle was a conversation today. It's critical is how do you store result of sports team on chain, so then other developers and projects can build maybe sports betting, maybe some rewards mechanisms that because I own a Paris Saint-Germain token, I'm going to get a free NFT tonight that is minted automatically because they scored 3-0. But how do you know that they scored 3-0? Well, you need to have on-chain data. The problem is, where do you get this data? There are providers who provide this data, but they don't want their data to go on-chain for free and everybody to be able to access to that data forever. So there is some complex things around that. But for us, it's all about engagement, transactional, and it's a bit limitless because we started with the sports space and we have only 100 teams more or less all over the world. But then there is a few hundreds more that we have to go after at some point. We launched one of the biggest Premier League team, Tottenham Hotspur, a month and a half ago. We already have 6 or 7 other Premier League teams, but we will have more eventually. And we keep have markets, new markets where we can develop stuff. But again, our goal is really to make this chain not the fastest, not the best, but just the sports blockchain, or the one that at least deliver utility for real users and mainstream users all over the world. In terms of price for today, I'll jump on that if you want. I don't know if, yes. So there is 2 categories. So it's a 20K price, 7.5 for the fan utility token. So literally focused on what I said about these fan tokens. So what are whatever feature or product could come to bring more utility to these tokens. And there is a second pool for the so-called SportsFi project, which are more neutral, maybe less fan token oriented. Could be a DEX, could be a lending, could be whatever other ideas, betting, lossless betting, I don't know what is that, and many other things that can be invented. And then there is an extra 5K for generic pool price, I suppose. That's how we start at least this weekend. That's on you, of course, to go after that and to chase this. Hopefully, please tell your friends as well that Chiliz is cool. It's spicy, but it's cool. And you know, unlike most of the other companies, blockchain, project, foundation, whatever that you've seen here, is everybody's doing the same thing. Objectively, all our neighbors, it's all either layer 1, layer 2. I mean, at the end, it's everybody the same thing. Everybody's poaching a developer to say, oh, I have a lending protocol. Oh, you can do it on my new chain. It's amazing. Great. And it's cool. For you, it's cool because there is always a new girl that you can try to date and get money out of it. Good for you guys. For us, it's a little bit different. We are trying to convince developers that, hey, maybe it's time to actually build utility on this blockchain and changing the narrative that it's all about money, 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 and actually bring interest for users to actually use the blockchain that is not just about an ETF in Bitcoin and it's not just about the tokens going up. And that's where I believe Chiliz can bring value to the users, to the fans, to the developers, developers being either independent or eventually being funded to do more with us or with someone else. That's more or less the idea. Should I add anything, Max?
We're about 20 minutes over.
That's great.
We were going to open
Q&A after that, in case you guys had any questions specifically about the chain and how to access our testnet.
Go, James.
Yeah, I mean, it's pretty straightforward. Like Alex said, it's an EVM chain, so it should be self-explanatory. We've created this doc on docs.chiliz.com. So yeah, docs.chiliz.com. It should be on the QR code of the flyer that you can get from our table. You should have everything here. So you have the video. If you keep going through the video, it's going to go through a section where it kind of gives you a walkthrough of the docs, of how to bridge, how to use the faucet, you know. And then after all that, you will have the price pools and some more useful information that we thought we'd throw in that you guys might need, including minimum gas price. We have a lot of people who complain about the gas limit because basically when you deploy on our chain, there's a bit of a more complex system smart contract. So just up the gas limit a bit before you deploy to save you a bit of hassle. We have some links to our testnet, our faucet, like I said. You can see it right here. So it's linked to Twitter, so you can verify with your Twitter, and you can get 25 Chiliz or some fan tokens to play with as well. And we also have wrapped Chiliz. For mainnet, to get Chiliz, you can use our bridge between Ethereum mainnet and Chiliz chain. But we recommend that if you have Chiliz like on Binance or on any exchange that has connected to Chiliz chain, you can use that as well. And we also have some dev tools that are already there. Obviously, I was speaking to actually one of the guys here. You guys are used to a bad developer experience, but if you guys want to use our tools, we partnered with Morales, Tatum, Third Web, WalletConnect, Magic Link. There's some others as well. If you need anything, just let us know and we can let you know. We have an Oracle, ETH as well. I can add it as well in the list here. But basically, this is pretty much it. We're open to any questions, so go ahead and throw them our way. Yep.
Yeah, you spoke about you have an Oracle.
Yes.
But it's also like it's also in the things you are looking for. Like
so the Oracle we have right now, it's for price data, right? So we can look for oracles which get different types of sports data, like Alex was mentioning.
Like match results.
Yes, exactly.
So ETH just launched their token yesterday. They integrated the Chiliz chain to distribute price feeds because they are DeFi oriented. But what we are looking for is more like trying to create a sports oracle where we can store match result, real time, not real time. The question is, how is it validated? Users, not users, third party as companies. There are a lot of feeds available in the market, but how do you make it on chain? How do you scale it so developers can build tools with that oracle?
Any other questions?
Is there any limitation on what type of smart contracts can be deployed, or?
No.
Okay, since you mentioned before, the deployment can be expensive due to the governance.
So we made some changes in the governance, the system contracts, because we used to be a permissioned chain before.
Okay.
So we made some tweaks. The tweaks are still there, so it might be a bit more complex to deploy on chain because it's checking a lot of extra functions in the system smart contracts. You just need to increase the gas limit a bit higher than what you would usually do on other EVM chains, and you'd be good to go.
That includes also other ERC20 tokens that can compete with the ones you already have on the chain? Like, can I create another fund token myself?
Yeah, of course, we want to open up kind of the ecosystem to have maybe more sports brands.
Yeah, we actually have, so there are, here in Turkey, for example, there are 2 exchanges that used to launch tokens, fan tokens. Actually, fan token is a trademark that we own. Different topic, but There is an exchange here called BitXN here in Turkey. They have 15, 20 tokens that are very different than what we do. But they are actually launching them. They are minting them on the chain, on Chiliz chain as well. Because eventually what's going to happen, if we all do well our job, but that's what's going to happen, we will be the chain where people, if you want to mint a fan token, even if you're a small rugby club in South Africa or in Ireland or in New Zealand, eventually people will mint their fan token on the Chiliz chain because there will be a bunch of tools dedicated for that space. So till now, we as a company, we were the issuer, the minter, master minter of fan tokens. In 2 years, we hope there will be thousands of legitimate, that's the only issue, but legitimate clubs and sports property that has nothing to do with us, that will deploy through whatever platform their fan token, and then it will be, they will have access to all the tools that are provided by the chain.
Thank you.
Thank you very much.
That's okay, that's it, bye. I thought it was a question. Thank you.
So I'm Tom, I'm representing WalletConnect, and today I'm going to be presenting around building dApps notifications with Web3 Inbox. So yeah, just a bit about myself. I used to work in social media and marketing, and then I moved into software engineering, and then now I move into dev relations. I spend a lot of my time thinking about the next future of wallets. We've had wallets from a very long time ago, and then now we have a new era of wallets and dApps that I'm really interested to talk about today. Cool. So for those that aren't familiar with WalletConnect, a disclaimer, we are not a wallet. We're a wallet and dApp infrastructure company. So you might have seen our QR codes quite often around the place, and we power many millions of requests per day. And basically, yeah, we try and build and bridge the gap between dApps and wallets that you may have known of. So we are actually two different parts. So we have products, and then a lot of things that you might have used this QR code on is primarily built on Sign API, but we have all these other cool APIs which make up our products. So I'm just going to quickly, for today's context, just go through what is WalletConnect, of course talk about the bounties, because that's what you're here for, and then I'll talk about Web3 Inbox and how you can build some cool experiences. Cool. So Web3 Modal is the flagship product that we started out with, and it's around connecting your wallet to your dApp. So this is if you've ever been a dApp developer or someone who's interacted with a dApp on the right-hand side of Connect Wallet, that's what this serves purpose on. So 500 different wallets, and something I want to talk around 6963. And then we have a few more cool things around embedded wallets, around email coming soon. So there is this problem in the Ethereum space called the injection wars, or window.ethereum. It's an absolute nightmare. And the way it works is you have MetaMask and you have Phantom, then you have a Cosmos wallet, and then you try and use MetaMask, but then the other wallet pops up and things like that. So this is dependent on a thing called window.ethereum, and that is like solved. So if you ever had the whole MetaMask and Phantom wallet, all this kind of cycle, like that's over. So if you see on the left-hand side on wallet Web3 modal, you can see that like you can choose your injected wallet. So that's a cool thing that we've worked on in the open source space to get forward. And we support several different types of wallets in the space. Web3 wallet, so if Pepe wants to connect to airdrop.pepe.io, kind of looks like a scam. So this is something that we've been working on. So Web3 wallet is if you're a wallet developer. So if you've ever used MetaMask, Trust Wallet, and things like that. And we really think about, how do we help wallet developers, but also how do we give more verification and security features towards them. So that's something that we've been shipping. And most importantly is multi-chain. Like things have changed from 2014 to 17. Like we have a lot more networks, and that's an experience that we wanted to deliver. And this is the one that we'll be going through more in the workshop. But I really what we have now is push notifications, and chat is coming shortly. And we really want to think about, all right, you've built your dApp and wallet, how do you build more engagement around it? So I'll be going into this a bit later, but essentially we really want to think about the Web 2, Web 3 product experience. Cool. So this is what you guys are here for, of course, among some other things, to network and do all the cool things. So we have 20K in total bounty prizes. So the first one, which I'll go through in a lot more of this workshop today, is around Web3 inbox. So the best integration, a total prize of around 7K. So that's, I would say, one of the higher pool prizes we have, the prize pools. And then we have mobile. So we're very bullish on mobile. We started, and we've helped a lot more mobile wallets integrate. But this is also on the dApp side. So Web3 modal is the dApp side. So if you're a mobile developer that can build on React Native, Flutter, iOS, or Android and Kotlin, like that's all supported. So there's 6K up for grabs for that one. My alpha is not many people will be doing this track, so, hint, hint. And innovation pool prize is that this is for just a pool prize, and if you make some sort of, basically if you integrate Web3 modal, the connect wallet button, but also make an interesting experience. Don't just, npm install and call it a day, right? So you need to do a little bit more than that, but that's what we're looking forward to amongst Web3 wallet if you want to integrate that. So those are our two things that qualify for the pool prize. I would imagine most of you would be qualifying for this one, but also if you're here for inbox, I'll go into that. Cool. So this is something that I guess you are all familiar with. And I want to ask raise a hand of a question. How many of you do on-chain transactions every day? Every day? Are you sure? 1, 2, 3. All right. We got some degens here. So this is actually quite rare. Every time I've been in an audience, there's only been one person putting their hand up. So making on-chain transactions every day to weekly to monthly, like everyone has a different time period. But we want to get to a place that if you think about your Web 2 experience, you use Instagram or TikTok, and you're kind of in this dopamine wheel effect, and you're using it and you're starting to enjoy the product. But Web 3 kind of doesn't have that. We're still stuck in the just, I'm going to stake my ETH and I'll come back to it, and then I have to check in-app, I have to log in again and do it, and I don't feel like that's the experience that we want to go towards. So I personally spend a lot of time talking to wallets and dApps to figure out what is happening in the space. We get to talk to 300 plus wallets and many hundreds of dApps as well. And I think it's been harped on for a long time, hey, let's fix crypto UX. But I feel like we're in the latter half of really starting to solve it, namely things like account abstraction and all of that.
But the way I see dApps right now, and most of you will end up building dApps during this hackathon, is this is kind of the categorization in my head that works around what dApps are. So, and then you see these features in wallets. So you financially read or write, you send ETH, you send Sol, you receive Sol, whatever. NFTs, you can look at your, Punk or whatever else, and you can send it, interact with any of these contracts. You have identity with like decentralized identity with Disco, Lens, ENS, like all these things, all these pieces are here around multi-chain, and more recently and more popular is like SocialFi and this whole thing of consumer crypto. I'm personally not like really with the whole consumer crypto thing. It should just be consumer and like just use and build things that people need. So that's the main thing that's being talked about these days. And we think a lot about this Connect wallet experience. And the thing is, right now is the left-hand side of where we sit. We sit in a very token-centric like system, and DeFi and NFTs are leading the use case. But right now, I can only see 5 people here who put their hand out of 20 to 30 that are using on-chain transactions every day. So I think things needs to change, and we're not going to be able to solve it overnight. But our thesis around Web3 Inbox is really thinking around communication. So Web 2 products easily, like if you think about the onboarding experiences with like sign in with Google and this and sign in with that, and then you can easily use these products without having to do all these transactions, right? And that's what we want to get towards. We want to go towards that experience where like notifications, messaging, communication is like all actually properly working, and it feels like native towards the experience that we have, in Web 2. And the last part I kind of want, my personal take as well, is that wallets are no longer this transactional like list. You go to Etherscan and you're like, oh, these are the things that my wallet did. But I think we should start to reframe mentally like what we think a wallet is. And we believe like a wallet is more like an identity hub that allows you to interact with the rest of consumer crypto, or however you else want to phrase it, because it's no longer a transaction list. We can do so much more. And I feel like as developers or as product people or business people here, we need to start thinking about wallets not as financial lists, transaction lists, but as an identity that allows you to do things. Cool. So with this in mind, we really wanted to think about like notifications, like whether it's like OpenSea or Foundation or Zora that you're minting, or snapshot proposals or swaps, or like whenever your stake has reached a certain amount, and a lot more thinking around, or even ENS domains, like I have to regularly check in on my ENS domains to see when they expire, or if I can buy someone else's. So all of these things are still kind of missing, and we really want to do like a full product experience where it actually feels native. So yeah, like just kind of want you to pause for a minute and start thinking of like what this experience means more. Like, sure, it just looks like another iOS notification button on your phone, but I feel like this experience is going to help us more like feel more engaged with what's happening with like consumer crypto products. Cool. So this is just a GitHub template if you end up wanting to work on Web3 Inbox. This is all the instructions, and it's a quick guide to. I can give you the information on this a bit later. So what I'm just going to go through over the next 5-10 minutes is just go through the code to show you what that experience looks like, and then I'm happy to take some questions at the end. Great. So this is mainly initially for Web3 Inbox's JS. So it would, just your standard packages, npm, bun, yarn, whatever else that you want to do. You'd add in some environment variables here. So you need a secret for your using notifications. And then here is just pretty much like a sample, like I guess, body of what it would mean to like just send a notification. We really wanted to make it as simple as a Web 2 kind of style of just, sending it through to this. Title, body, whatever you want to do, and whoever account that you want to send it to. So this is something I'll show you a bit later, but this is just a quick callback in React, and just showing you like how simple the block is of if you think, say, let's just take a DAO proposal notification app, for example, right? And then you have your DAO vote, and then it's like, oh, it's been passed. All the front end and the back end has to do is be listening for that event, and then you can easily send these kind of notifications. Cool. So I'm going to switch over to the demo here just to show you what this experience looks like. So just as a heads up, this is what you will spin up easily just from an npm install from that code snippet I showed you. So basically, you just connect your wallet here, and what you do here is we've taken an approach of like, there's a lot of spam that can happen if you were to receive notifications or chat. So we've taken a decentralized identity approach, as you can see on the, it says did. That's just a kind of like a way to standard around it. So basically, you're just signing authorization to this application. Hey, you don't, like, we give you access to talk to us, as opposed to just getting spammed. So this is just that. So this is just authenticating the signing. And then this is 0x87. And then I'll be subscribing to this application. So here, there's nothing that's been subscribed as of yet. This is just some further information around it. And what is actually just about to happen is now this application is event listening to every single block that's been happening. So listening for on-chain events. And that's where I would assume that any of you who is hacking on all of this would be thinking around, what on-chain event can we start to think is more exciting towards the consumer and something that I can get like excited about? Like I'd want to know when I get liquidated. Like these kind of things are going to want you guys to start thinking about. So that's that. So this is just running in the background for the block. So that's that. I think soon enough there will be another block that's mined. And then I want to send a test notification. So this is something that you can also programmatically create of, okay, so you were listening for on-chain events. What if you want to do a different type of messaging? So there's two different ways that you can do it. Cool. And then the way I kind of want you guys to think about it is this is the dApp side, or this is the app. And then if you think about it on the wallet, which I'll kind of show you in a little bit, is, okay. All right. So we have this thing called app.web3 inbox. So this kind of think about Web3 inbox, kind of inbox, think about your Gmail, think about it as where you get all of your messaging. So what we did is on this app, I connected 0x87. And then this one, I'm subscribing to the app I created here on 0x87, just as a verification. And it should kind of come up as part of like your inbox. So then if you compare, like I mentioned, left-hand side is your dApp, right-hand side is your wallet. So right now it just mined a new block and all of that. So all of this is working, synchronously, on the app side and the client side and the wallet side. So this is kind of the experience, and I want you guys to think about like, what if this experience was native to your phone? So that's kind of where we're trying to go towards. Cool. And yeah, so I'm pretty good to wrap up, a bit shorter on time, but that's fine. And yeah, so we're hiring 2 product managers, if that's of interest. Documentation's there, GitHub's there. And yeah, thank you so much, and looking forward to seeing you guys hack on WalletConnect. Cheers. I'm happy to take any questions here or outside, so cheers.
Hello. Hello everyone, I'm Alessandro and today I'm going to talk to you about Hashi. Hashi is a protocol for cross-chain communication that allows you to send a message using more than one bridge. What? Okay. Okay. Hashi is a protocol that allows you to send a message cross-chain using more than one bridge. Just to give you like a little bit of history that I'm sure you know it. We have seen in the past years that many losses were caused about basically bridges, and users at the moment don't trust bridges anymore because, because putting, all your trust in a single bridge is very dangerous, since you cannot like be sure that that a bridge is free of bugs. Also because like building a bridge is very difficult, since a bridge is composed by many components, and be sure that it's completely free of bugs, it's very difficult. Also, you know, if you do a lot of audits, you cannot be sure that basically you don't have bugs. So for this reason, there's need a paradigm shift in the bridge design. So what is Hashi? Hashi is a protocol for cross-chain communication that allows you to send a message cross-chain by using more than one oracles. So the goal of Hashi is to basically distribute the trust among independent oracles, since in this way it will be like very difficult to break them all at the same time. So now let's move maybe on the most technical part. How to send a cross-chain message with Hashi. Okay, so the entry point here is the YAU contract on the source chain, which is, let's say, the main contract that allows you to interact with the underlying message relay contract. For each oracle, you need a pair of contracts, a message relay 1 and an adapter. The message relay 1 is the one that is in charge to interact with the underlying bridge contract, while the adapter is a contract that just stores the hash sent from the source chain. Then, when you want to send a message, you have to call the dispatch messages function, the dispatch messages to adapter function inside the YAU by specifying the list of adapters and the list of relayer that you want to use, and obviously the message. Then YAU, for each message relay, will call the underlying message relay by calling the relay messages function. So in this way, each message relay contract must implement the relay messages function. And inside of it, each message relay will call the underlying contract of the bridge. Then, when all bridges will have processed all message independently, you can execute the message. What you need to do is to basically, you have to wait all oracles that will have processed the message. And then you can call the execute messages function on the YARU contract by providing the original message and the list of adapters that you have used. YAU then will just basically calculate the hash of the original message that you passed, and we will compare it with each hash stored in each adapter. If there is consensus, the target contract can be called. Now, guys, I will show you some code that shows this behavior. So, okay, this is just a simple ping-pong contract which has two functions, the ping one and the pong one. The ping one just calls the YAU by specifying, sorry guys, the message relays and the list of adapters. It just encodes, let's say, the function signature to call on the destination chain, which is this one. Then for each adapter, YAU, which is this contract. Let me show you. We'll call each message relay. So let me show you our message relay is done. Very easy. Let me show you maybe the AMB one. It implements the relay messages function, and inside of it, it just calls the AMB bridge. And this can be done with like many bridges, also with like ZK, like client or ZK bridges. Then, when Yaru will execute the messages here, it will need the original messages, the message IDs and the sender, but these are just needed to calculate the hash, here. It will compare the, wait a second, sorry. It will compare the hash, the hashes, sorry guys, the hashes here. If the hashes are equal, the target contract will be called. In this case, will be the function that will be called will be the Pong1. So the Pong1 will just check that the sender is Yaru and that the source sender, so the sender that initiated the transaction on the source chain, is actually the other ping pong. And then it will just emit an event. Super simple. Then let me show you, maybe, okay, ping pong. This is on Go Early. Now, let me show you, okay, contract. Okay, now for simplicity, guys, I will just use the one bridge, since on testnet we don't have it many, so I can just use one. But if you like ping, wait a second. I don't want to sell anything. Okay. Okay. Now I'm going to call the ping function. Okay. Okay. Let's wait for the confirmation. It should be like very fast. Okay, you can see within the logs that YAO contract emitted an event which is called message dispatched, which contains the message ID, the data, so the Pong function encoded with the corresponding parameters, and then some events emitted by the message relay. Then on the other side, when you want to execute the message, you need, first of all, be sure that the underlying bridge will have processed the operation. Yeah, it has. Now, within the Yaru contract on the destination chain, you need when you want to execute a message, you need the sender. So, I mean, the ping pong contract on the source chain, the destination chain ID, which is Gnosis, and the data. The data is this one. Okay. I'm sorry. Okay. Message ID is it. You can take it here. It is 5. Sender, okay, okay. Now I will execute the message. Wrong network, okay. Okay. Okay, here you can see that the message execution has been completed. Let's wait for the confirmation. Okay, you can see that the Pong event has been emitted. So basically, if we had like used more than one bridge, you had to like wait for all bridges and then call this function by providing the list of all Oracle adapters here. It's really easy. Then I will come back to the slides. Yeah, just to show you if you wanted to like build a message relay or an adapter. This is the way. Let's say it's super easy. The message relay contract just need to implement the relay messages function, which call again the underlying bridge, and instead the adapter must implement a function called store hashes, which just store for each source ID the message IDs and the message hashes. Now I will leave the talk to my colleague Zen.
Thanks, Ale. Hi, I'm Zeng. So instead of, besides relaying a message using Hashi, we can also like relay the state of a source blockchain to another blockchain using the block header. So it's very similar to relaying the messages. So instead of like relaying, so you can see like the white part is the underlying bridges, and Hashi is just a bunch of like smart contract on top of them. So what you can do is like, for example, I want to relay block 100 from Ethereum to Gnosis chain, for example. You can call this header reporter contracts on the Ethereum, and you specify which block number you want to call and what is the destination chain you want to pass to. So once the contract function is called, it will store on the destination adapter contracts. And where does the security comes in? So instead of like calling A and B to relay the functions, I can call like connects, wormhole, like for example 5 bridges to relay the same block numbers for me, and they are all passing through the bridges and store in the adapter contracts. So like where Hashi comes in is that you can think of like Hashi like a multi-sig of bridges. So you can define your threshold. For example, I want 5 out of 3 bridges to store the, if I specify the block number and I call 5 bridges to bridge the same block headers for me, and let's say if 3 out of 5 of them store the same hashes, then I can assume that the block header is correct. So that is where the additive security parts comes in. So if you want to interact with Hashi to relay the block headers, it's really that simple. You call the reports headers function on source chain, and then you call the get hash from oracles function from the Hashi contracts. And yeah, so from the source chain, we have this header reporter contracts. As you can see, we specify the block numbers and which adapters we want to use, and also the guess. And once the contract function is called, it will emit this header reported event. So the ID is the block number, and the block hash is the actual block header from the source chain. So after the function is called, it will be stored on the destination chain with hash store events emitted. And yeah, the ID is the block number, and the hashes is the block header. And what you can do with the block hashes is a lot of things. So like you can verify the states from the source chain. And for example, back to the ping pong example that Ale demonstrated, let's say I want to check if an event is emitted from Ethereum, and I want to check on the Gnosis chain. So now we can like have 2 parts to check. First, we can check if the block header that Hashi relays is correct. Is correct. And then we can check the receipt routes and the receipt related data that we fetch from source chain RPC is correct. So let me show you like a simple code. Yeah, so this is the interface of Hashi contracts. So we call this get hashes from oracles with the oracle adapter's address. So like for example, I have called 5 bridges to relay the tokens, relay the block headers for me. So here I need to specify all those 5 oracles address here. And domain is the source chain ID. So for Ethereum is 1, Goerli is 5, and the ID is the block number. And what it does is we'll just get all the hashes from these oracles individually. And as you can see, it returns an array of hashes. So besides on that, and you can build like your customized what you want to refer from these hashes. For example, if you think like ZK-like client is more reliable, you can just call 5 ZK-like clients and get their block hashes. Or you just want to hash some, for example, I can add some multi-sig multi-sig oracles. You can just specify your customized logic that you want to check. So yeah, so back to that emit events example. On the destination chain, how do we verify the state and the receipt is correct? So yeah, so in this example, we are going to verify the Merkle proof of the receipt is correct and also the block hash. So first, we define the inputs of the proof. So like here are the receipts related data that you fetch from the source chain. You can just call like get transaction receipts and also get blocks to fetch all this data, and also the log index in the block regarding to the event that you want to prove, and also the block header. This block header is the RLP encoded block header elements like parent hash and state roots and transaction roots. So you can like basically recreate the block hash by hash kcat 256 hashing this block header. And now we deserialize the data. And now the first thing we have to check is if the block hash that is stored on Hashi adapters are correct. So first we use this block header that we provide. We can fetch it on RPC on the source chain, and then we call this like reported hash. And then we fetch the hash from Hashi that you call those individuals oracles to pass the block header to. And it's like just return a bunch of block hash. So yeah, we can check that if those 2 block hash are correct, then if it's correct, then we can assume that this block hash indeed is correct. And yeah, and the next logic is just checking the receipts, checking if the emitter address is ping pong or not, and if the topics is the actual ping events topic. And also we can verify the Merkle proof for the receipts. So once it is like verified, you can define your own dApp logic like airdrop or cross-chain governance or just sending a tokens. So yeah, that's a very simple use case for that. And let's say if you want to use Hashi, but your oracles that you want to use doesn't exist yet, you can build your own adapters and header reporters on both chain. So it's very simple, just a few lines of codes. So first on the source chain, we have to like inherit these header storage contracts, and then we store those block hashes. And then here is your oracles or bridge customizing logic to relay the message. For example, CCIP, you can use CCIP send, and other oracles, you can use different methods to pass the message. And also you have to emit the header reported event. And on the destination chain is where the oracles call this adapter contracts store hashes function that will eventually store those block headers on your destination chain. Yeah, so that's a very simple use case of relaying a token. If you have any questions, feel free to check out our docs and GitHub, and also, Discords. Thank you.
Hello, test. Okay. Out of curiosity, how many of you were at DevConnect? Just ETHGlobal? Oh, okay, cool. All right, so this is a talk about Zupass, which I'm sure probably almost all of you interacted with. I'm going to be talking about what exactly Zupass is, why we built it, some of the things you can do with it. The framing of this workshop is I'm not going to be walking through a lot of code. It's going to be a quick introduction, and then I'm going to potentially have time for questions, but probably not. So I'm actually just going to delete this. Okay, we're going to pretend that I'm onboarding you as a new member to the team. Okay, so Zupass. What is Zupass? Here are a couple of screenshots for those of you who haven't used Zupass. Basically, it's kind of like a cryptographic file system. You probably experienced it as a ticket delivery mechanism, but in reality, it's a cryptographic file system. So the objects that exist in Zupass are PCDs. So these frogs are PCDs, your tickets are PCDs. PCD is an acronym that stands for proof carrying data. I'll get into what exactly that means, but first I'm gonna kind of frame what is going on here with a couple of analogies. So I'm sure you guys have seen like Gmail or email clients. Gmail is an application, and what it lets you do is it lets you operate on these objects called emails. So you can send, receive, compose emails. Here's an example of an email. There are many different applications, and a lot of the applications that you interact with, they have like an affinity for a particular type of file. So like Microsoft Word lets you operate on Word documents. Anyway, you get what I'm talking about. So Gmail lets you send emails. Zupass lets you operate on PCDs. So in the same way that like Word lets you edit or create Word documents or receive Word documents from somebody else and edit them, Zupass does the same thing for PCDs. Okay, so what exactly is a PCD? A PCD, proof carrying data, at the most basic level, oh man, that is really terrible. Let's see if I can zoom in. Okay, so this is a screenshot from our code base. We use TypeScript. A PCD is an interface, and at the most basic level, these are the only two fields that are really important. A PCD has a claim, something it's saying about the world, and it has a proof. The way that the two are related is that the proof is a proof that the claim is correct. So PCDs are intended to be like atomic pieces of data that are self-evidently correct. So a really basic example of a PCD is a prime factorization. So let's say that you have like a really big number, that would be your claim, I don't know, like 12, for example, and a proof that you know the prime factorization of this number would be the array 3, 4. And somebody can look at this thing and trivially verify it using some math or some algorithms. So the idea is there can be many different types of PCDs, and we've built like an SDK and a framework and an application that lets you operate on these things without really caring about what exactly it is they are. So you can have prime factorizations, or you can have frogs, or you can have tickets, or basically anything that you want, as long as it's of the form that is a claim and a proof. So this interface has a couple of other fields. ID, it uniquely identifies a particular PCD and a type. So there's many different types of PCDs. For example, in the prime factorization situation, the type would be the string, I don't know, prime factorization or something like that. Okay, so Zupass, it lets you hold a bunch of these PCDs, and the other thing it lets you do is it lets you do stuff with them. So what exactly can you do with a PCD? Well, obviously you can prove a PCD, i.e. like create a new instance of one. You can verify a PCD, i.e. like check if it's correct or not. Another thing that you can do, oh man. Another thing that you can do is you can make zero knowledge proofs about the PCDs that you have in your Zupass. Yeah, I know I described PCD in this like really abstract manner. They're like self-evident pieces of data that you can verify are correct based on the proof and claim. But what we're really trying to do is make it really simple and easy to build applications that let you make use of zero-knowledge cryptography as a developer without really having to understand the cryptography, because it's kind of a complicated thing. So I have Zupass open here. This is a local version. So it's like a cryptographic file system, so you can think of these as folders. So for example, in the DevConnect folder, I have several subfolders, and here I, for example, have a ticket to the event called ETH Next. So this is a PCD. Under the hood, it's one of these guys, but it's rendered in this particular way. And then I have another folder here. It's called Frog Crypto. My local version doesn't have, unfortunately, like the actual images. I didn't set that up. But this is a picture of a cute frog, and this is another PCD. So what are these things actually? Well, these two different things I showed you, the ticket and the frog, they're instances of a type of PCD. So the ticket one is called an EDDSA ticket PCD, and the frog is called an EDDSA frog PCD. So EDDSA is a signature or like encryption algorithm, kind of like RSA, if you're familiar with that. EDDSA lets you sign stuff. So an EDDSA frog PCD is a JSON that has been signed with a particular EDDSA private key, and it's represented as a PCD, so it's got a claim and a proof. The claim is some representation of that JSON, so the frog has like different attributes, like the jump attribute, or the vibe attribute, or the speed, or intelligence, or beauty. So these are like fields in this JSON, and the PCD has all of these fields encoded in a particular way, and it also has a EDDSA signature, which would be also in the claim. No, it would be in the proof, and then you can take the EDDSA signature, which is in the proof, combine that with the public key, which is in the claim, combine that with the frog information, which is also in the claim, and you can trivially run an algorithm to verify that this is like indeed correct. So PCD is one abstraction that we have in the system. Another abstraction that we have is called a PCD package. A PCD package basically defines a new type of PCD. So the EDDSA PCD has a PCD package. The EDDSA frog PCD has a package. Maybe I will actually open some code so you guys can see. So EDDSA frog PCD, you can see that this is just like simple TypeScript, and I have this like frog data thing, name, description, image URL, and over here I have defined a type called EDDSA frog PCD claim, which is the frog data, and then I have an EDDSA frog PCD proof, and inside of it I have another PCD, funnily enough, it's frogs all the way down. So this thing actually has you know, the thing I was talking about, public key, a message, and then a signature and the proof.
Is the user ID in the claim?
Is what in the claim?
A user ID, or how can I say that I own that frog, or are the frog the same?
Good question, yeah. So the thing that is in the EDDSA frog PCD, frog data, owner semaphore ID. So every Zupass user has a Zupass identity, which is in reality a semaphore identity. I don't know if you guys are familiar with semaphore. It's a protocol that lets you make group membership proofs. So you can like make statements on behalf of several identities, and then the zero knowledge proof basically proves that one of these people with these public keys said this thing. So yeah, the frogs are soul bound in a sense. Oh man, okay. Where was I? Okay, so we've got PCDs, we've got different types of PCDs. I talked about like frogs, I talked about tickets. I was just showing you the notion of a PCD package. So like, here is the PCD package. All of these different types of PCDs are NPM packages. You can install them key, we publish the public key and all of the frogs that exist in the world right now. By the way, there's 70,000 of them, which is crazy because you can only get one as frequently as once every 15 minutes. So that's like a lot of man minutes wasted on frogs over the course of DevConnect. Yeah, okay. Any other questions about what a PCD is, what a PCD package is? Is this making sense? Does it? Yeah.
So, if I understood it correctly, it's not adding any new cryptography or any solution, just a way to structure data in a new way. So
exactly.
When we transfer some proof, the structure will be fixed.
Correct. Yeah, so that's what's going on here, and Zupass is like a place to put all of those little instances of data that are structured in this particular way. And now I'm going to get into what exactly you can do with them, which is make zero-knowledge proofs about them, or like that's one of the things you can do with them, I guess. So there's this website that we built in order to like test all of the stuff that we're doing locally. And I'm going to go to this page over here. So it's really ugly. It's not super interesting. But it does what it says it does, which is pretty cool. So I have this button. It says request Zupass event ticket proof. And when I click that button, a pop-up opens. And this pop-up is actually Zupass. So this pop-up is the same website as I have on this big site. And what's going on here is that this third-party website, which is, as you can see on a, I guess maybe you can't see, it's on a different port. This one's 3001. This one's 3000. Anyway, so what this pop-up is it's this link is a link to Zupass, and then after this hash, man, maybe I can open this in like text edit. So you've got this really big URL, right? And you can see it's got request equals. So there's an API that allows third parties to ask Zupass to do stuff. So this particular instance of an invocation of this API is asking Zupass to make a zero-knowledge proof about a ticket. So a ticket is an EDDSA ticket PCD, which is EDDSA signed data. And now, using this pop-up, I'm going to make a zero-knowledge proof that I have a ticket to a particular event ID and product ID without revealing any of the other fields of the ticket. So the ticket has a bunch of other fields, EDDSA ticket PCD. It's got an event name, ticket name, image URL, blah, blah, blah. And most, I guess, like importantly, it has like an attendee name and attendee email, which are things that you may not want to share with a third party when you're proving that you have a ticket. So you could imagine somebody like, for example, wants to build a website for all DevConnect attendees to be able to like log into and like have a forum to talk about stuff. One way you could implement that is you can make them give that website an instance of a ticket PCD, or if you're like more privacy conscious, you could ask them to make a zero-knowledge proof that they have a ticket that was signed by like a valid signer, and it was a ticket to this particular event. So that's like an example use case. So when I click this prove button, this pop-up is going to generate a Groth16 proof using Snark.js, and then it's going to send that back using a clever window.opener API to this third-party website. And when I scroll down, you can see that I got a Zupass ZK EDDSA event ticket proof from Zupass. When I expand, you can see it's just a piece of data. So it's got a claim, which includes a partial ticket, which is the event ID and the product ID. It's got some extra stuff that I'm not going to get into right now. And then it's got a proof, which is a Groth16 proof. And then this website actually imports that same PCD package, the ZK EDDSA ticket PCD package. It uses that verify function that's exported by that package on this literal JSON that I just showed you, and it says that the proof is valid. And you can see that the only things that were revealed were the event ID and the product ID, and all the other stuff was not revealed. Okay, so this API from third-party websites to Zupass, it lets you make requests to instantiate a new PCD, and that UI that you saw is kind of, it's like auto-generated from what the inputs are to that PCD. I don't know if I explained that in a way that made sense, but every single type of PCD as defined by a PCD package, in order to instantiate it, you have to give it some information. And so Zupass allows a user to input that information into that prove function using this UI, using like maybe some PCDs that the user has in their Zupass, and in some other cases they're able to like type stuff in. So in the like prime factorization example, one thing that you could do is you could like ask for a proof of a prime factorization of a prime number or a non-prime number PCD that they have in their Zupass, or they could type in like 5 and 5 and get 25, and that would generate a proof or whatever. Okay, where was I? So that's what a PCD is. That's what Zupass can let you do. There's an API. So like one thing that we built using this in practice that is like more interesting than the stuff that I showed you. The stuff I showed you is just like random developer examples. So something that exists live and in production now is we built this situation you see on screen where people can use their DevConnect tickets to make zero-knowledge proofs that they have a ticket and then give that to a web server that permissions them to access a Telegram hub, which is a collection of Telegram topics. It's kind of like a mini Discord. So people were able to, in their Telegram, talk to this bot called Zucat. They type /start, and then Zucat opens up a web view inside of itself that has Zupass in it. The user logs into that Zupass in that web view, and then they see that exact same screen that I was showing you in the pop-up. They click prove, thinks for a little bit, calculates a bunch of numbers, gives it to our web server, which then lets that user into the Telegram hub. So that's like an example of something that was built in production. So that's like stuff that we built, stuff that exists now. I also wanted to like expand your mind a little bit and think about the possibilities about like what are the sorts of things PCDs can be. So far I've talked about EDDSA signatures of data and then interpretations of that data as represented by the ticket PCD and the frog PCD. We built those things in order to try to actually get users. That's not what we're really trying to do. Like, we're not really trying to make a really awesome ticketing experience. Like, you may have heard of like Unlock Protocol or something like that. Like, that's not what we're trying to do. What we're trying to do is bring this PCD vision to life, where you have a bunch of these like PCDs flying around and people, make proofs about them and talk to each other using PCDs. Anyway, so here's like a cool example of a PCD one might have in the future. There's this project called ZK Email. ZK Email lets you make zero-knowledge proofs about emails that you received. Every single email anybody receives these days is signed by the mail server that is sending that email. So if you go to your Gmail and you click the 3 dots, you can download a raw version of your email, and that email will contain a signature, and that signature corresponds to the public key of a particular email server. And so this ZK email thing, it is a project that lets you take that email, the full one with the signature, put it into a zero-knowledge proof as an input, and then it's combined with another project that lets you make proofs about JSONs inside of a zero-knowledge circuit and regular expressions. So basically, you can make a zero-knowledge proof that you got like an email from Microsoft with a job offer with a particular salary. Or you can make a zero-knowledge proof that you got a password reset from Facebook for this particular account. Or you can make a zero-knowledge proof that you got, a venture capitalist sent you a term sheet, and that term sheet like had a particular valuation attached to it. So all sorts of crazy stuff you can do with ZK email. So imagine you put an email, that raw email that you have downloaded from Gmail, into your Zupass, and then you're able to use Zupass then to like make arbitrary statements about that email. So like a third-party website might be able to ask you, give me an email with like from this sender or from this set of senders that like says this particular thing. And then you click a button, the pop-up pops up, it, thinks for a little bit, you do the thing. So expanding even further, any signed data, you can make interesting statements about, zero-knowledge proofs, preserve the integrity of information as it flows through like a DAG of these zero-knowledge proofs. Okay, so a couple examples that are relevant for you guys. ZooAuth, all of these links will be in a QR code. This is a starter repo that lets you use Zupass stuff to sign in. Don't take a picture yet. There will be a QR code with this link. So if you want to build with what we've got, use that for like a login type experience. And then if you want to give people PCDs, you can use this example issuer repo. And then Austin Griffith also has an example starter which integrates with the blockchain, so you can submit these zero-knowledge proofs to like Ethereum or something, and then somebody, I don't know if they use this, but maybe they use something else. Anyway, there's like a project that's live right now where you can use your DevConnect ticket to get testnet ETH somehow, somewhere. I haven't used it. Here's a QR code. Okay, that was my 20 minutes. I'm not sure. Do I have time for? Okay, sure.
Okay, you can go. Okay, no worries. So for the on-chain, the Austin Griffith, is that doing like semaphore proofs on-chain, or?
Man, I don't know.
Okay.
Semaphore is possible. I think it's either using a semaphore proof, so we maintain a semaphore group of all Zupass users that have a DevConnect ticket, or it's verifying the ticket PCD. I'm not sure.
So you could just do an EVDSA verification, right?
You can actually do any verification because it's actually just some like elliptic curve math. You can verify anything. It's crazy.
Yeah. The signature scheme, though, you would have to have a circuit for EVDSA, right?
Yeah, which in the reason we chose EDDSA in particular is because it's actually like pretty simple. Like there's a circuit you can import.
Cool.
Yeah. And in fact, if you look through our code base on Zupass, you will see like an example implementation of that. That ZK EDDSA ticket PCD contains SIRCOM code that actually has EDDSA verification inside of it.
Is it possible with Zoo to, like, for instance, list all the proofs, auditory all the carrying data? For instance, I want to get a list of all the frogs. Can I do that with Zoo, or?
That's a good question. So unfortunately, our API only lets you get a particular PCD from Zupass. You can't get multiple PCDs, but that's on our roadmap. That's like, I don't know, like I don't know when it'll come. I'm going to take a break after all of this. It was crazy.
So I would need to know the precise ID of a proof.
No, you can ask for a particular PCD type, and then Zupass will have a drop-down where the user can select the particular one.
And can I scope it by folder?
Hmm?
Can I scope the listed proof by folder?
No, you can't.
So it's going to be a list of all the proofs.
Yeah. You can like narrow down the tickets at least by event ID. Yeah, like in the future, ideally in the future, it would be really cool if there was like a Turing complete query mechanism that let you like ask for zero knowledge proofs about like arbitrary subsets of the PCDs you have in your Zupass. That's like part of the long-term vision. We don't have that now, but it would be cool. Sure. I'm not totally sure I understood this question. Are you asking about like, do we have a list of all of the PCD types? Yeah, so currently we are the only developers of PCD types, so all of them are in our repository. It's github.com/proofcarryingdata/Zupass, which you can find in a link here. Yeah, so there's like probably 12 of them so far. We accept pull requests also.
How do you store, like, I log in, it's email-based, Web2 server, and you keep track of all my PCDs?
Good question. So I didn't talk about that. Maybe I should have. So this is a end-to-end encrypted backup that you're getting. All of the PCDs are local only. You can actually see them in local storage, local storage.pcd collection. Here they are. You can JSON.parse that. But yeah, they're uploaded to our server using end-to-end encryption. That's derived from your password. So we don't see them.
I've also heard, random kind of question, but if you log in with another device,
If they click the forget password thing, then yes. If you remember your password and use it properly, then no. Okay, wrapping it up. One more question, or that's it?
If it's fast. Is there a way to contact the Zupass team for questions?
Yeah, create an issue on our repo.
Yeah, you guys can also like talk to them outside. Just need to get to the next workshop set.
Thank you. Thanks for coming.
All right.
So hey all, we are from Waku. Today we'll be talking about uncompromising Web3 communication at scale with Waku. So introducing Waku, it's a family of robust censorship-resistant communication protocols designed to enable privacy-focused messaging. The 6 values of Waku are listed over here. It's private, it's censorship-resistant, completely modular, adaptive, securely scalable, and rate-limited. So talking about the history, it all started with the Ethereum white paper in 2013 when the Ethereum trilogy was introduced, where Ethereum was said to be the consensus layer, Swarm for the storage layer, and Whisper for the generalized messaging. But over the years, there was not much of dedicated teams building on top of Whisper. And then in 2020, Whisper was replaced by Waku V1 in the status app. So this was a benchmark year, and today, Waku has evolved into a standard of Web3 communication. When I say standard of Web3 communication, it's because of the ecosystem that we've built around. We have status app using Waku, Railgun, which is a privacy layer built on top of Ethereum using Waku. The Graph is using Waku for decentralizing their indexes, and also XMTP is using Waku to build a specific use case, which is chat. So the key features of Waku are it's adaptive. It can cater resource-restricted environments like browsers, mobile phones, to resource-intensive environments like clusters, VPS, home servers and stuff. So it's highly adaptive. And it's rate limited by nature. We have rate limiting nullifier, which is a truly decentralized and anonymous rate limiting technology using ZK proofs. It's also open and permissionless. So Waku works on a content topic based architecture, and anyone can pretty much push messages into a content topic and subscribe to a content topic to retrieve the messages. To get started with Waku, you have 2 ways of doing it. The first one is to operate a Waku node or to build on top of Waku. For operating a Waku node, you can do it with nwaku or Docker Compose command, or even dap node, which is just a few clicks for initializing your own Waku node. If you are looking to build on top of Waku, we have the following implementations, which is JS Waku, nwaku, Golang, Rust bindings, and C bindings. You can find all of these codes and SDKs open sourced on our GitHub. So the 4 main resources that I want to share here are the developer documentation, which is available at docs.waku.org, and we also have a list of example apps that use Waku. You can check it out at examples.waku.org, and you can also find the GitHub repository in the organization. And yeah, the GitHub has all the open source code. And we also have an RFC list, which pretty much has the specifications for each and every protocol in the Waku ecosystem. So I would definitely encourage you to check it out if you're digging deep into Waku. So for ETHGlobal Istanbul, we have bounties worth $10,000 up for grabs. So the first prize or the grand prize winner will be getting a $4,000 bounty for the best implementation of Waku. And we also have 4 different track prizes with $1,500 each. The first track will be Best Network State Goods with Waku. The second being Most Creative Use of Waku. Third being Privacy-Focused Projects built on top of Waku. And the 4th one will be Best Game or Marketplace built on top of Waku. One thing that I wanted to highlight is that we don't really encourage general chatting apps or traditional chatting apps. We are looking for more novel use cases through these hackathons. So try to be as innovative as you can. And yeah, we're expecting the projects to be in those levels. So finally, some use cases with Waku. You can build gaming apps, marketplaces, decentralized state channels, or anything that can be done with human-to-human or human-to-machine communication. You can also check out our curated list of ideas by the community at ideas.waku.org, which has around 50 ideas. You can also feel free to contribute to new ideas in the community. So we also have a Discord server for us. Feel free to drop in and ask your questions, and our developers are ready to help you out for the hackathon. So I'll have my friend Danish to do a quick demonstration of the JS Waku SDK. So we'll be building an app in the next 10 minutes.
Awesome. Hello, hello. I'm Danish. I'm a JS Waku maintainer. So for this quick workshop, we'll build, and Guru mentioned we're not looking for a chat-based example. So we're going to build a super simple app that gets you to vote on a specific question. So you'll have four options, and there's going to be a question. And generally, you'd go around doing that by using some sort of a backend, right? But for this case, we're going to use Waku as the networking layer for it, and we're going to propagate the answers of the users through Waku, and everybody's going to be able to see that. So I'm going to assume, does everybody here know about Next.js, like starting a Next.js project, right? Okay, so we'll skip that part. We'll go into a project that has Next.js set up, and you can use whatever front end you want, right? The second thing what we're going to do is we're going to have the basic front end laid out. That is not as important for the workshop, right? Front end can be whatever. We're going to focus on providing or integrating Waku as a networking layer to communicate the votes. So I have the project called Waquiz, right? And it's in Next.js. So opening this and zooming in, this is the basic Next.js structure, right? We have these config files, post CSS for some styling stuff, and what we want to look at is the app, right? Here we have the layout.tsx, which is by default comes with Next.js, so we're not much concerned about this. What we're going to look at is page.tsx, right? And here, this is the logo. We're not going to care much about the front end stuff. What is going to be interesting here is 4 things. We're going to keep it very simple. What do we want? We want to have a node. We want to be able to connect to the network. We want to send messages into the network and receive messages into the network. Now, what is this message, right? Let's start with defining the structure of the message. We say we have a question with 4 options as its answers. So we want to send or propagate knowledge about the question. The question is of, let's say, structure. It has an ID, which can be unique. The question itself, which is of string. The answers, the possible answers, and the correct answer. So defining the type, we're going to define a very simple interface. It's going to have ID, a question, and answer, which is the array of strings. Let's skip the protobuf definition for now. This is useful when we're sending the message into the network. Going back to what we decided, we need primarily 4 things. We want to start a node. We want to connect into the network. We want to get messages from the network, right? And we know what a message is at this point. A message is simply an object which has an ID, a question, and an answers key. So creating a node, right? Let's use this for reference. Let's comment this for now, and let's start from scratch. And let's also open the docs on the side, because that's how I wrote the code and how we should expect to write or get started with Waku. So going to docs, nodes and SDKs. Here you'll see all the implementation docs. Going to Waku SDK, let's go to sending and receiving messages using light push and filter. Light push is a light protocol that is used to push messages into the network, and filter is used to subscribe messages from the network. So that's all that we care about right now. Now, creating a light node. Creating a light node is literally just 2 lines of code. So we'll go here, go back to waku.ts, which is a file for us to keep all our utility functions. And let's call this create node. And it does not take any arguments. And that's what it does, right? Missing up. Yeah, perfect. It create light node, and we're passing it a parameter called default bootstrap. And what that does is it uses a predefined set of nodes that we're going to use to connect to. Otherwise, if you do not want to connect to pre-existing set of nodes that Waku has, Waku being a permissionless network, you do get to run your own node and participate in the network, and you'll get a multi-address that you can use to dial. So you do not have to use a pre-existing node. For simplicity, we're going to use the default network, and we're going to start the node. One key point here is going to be, we are attempting connections to the network now. We have to wait to ensure that we can use the protocol now. So one simple helper function here is what we call as wait for remote peer, and we're going to pass it the node. This function is pretty much all it takes to create a node. And at this point, if this function just returns cleanly, this means you are connected to the network, right? And now what we want to do, we want to be able to subscribe to the messages from the network. To do that, let's see how we do that. We've waited for remote peer, and everything happens. It's a pub sub architecture, so everything needs to be over a content topic. For this, we've set this content topic, and it can literally be anything. It can be ETHGlobal Istanbul, and it doesn't matter, right? Or we just need to ensure that the content topic we choose is unique to our own application. The next thing we want to do is, of course, we're going to be sending messages into the network and receiving messages from the network. And we used protobuf, right, to keep it. Yeah, we're going to, OK. Sure, yes. Why do we have to use protobuf? Because we are interacting with multiple implementations. So we need a way to serialize the message. Yes, you can. Yes, you can. So you can encode it. All it needs to be, So it needs to be serialized and deserialized in a particular standard, which is why we stick to protobuf, but you can send it however you would want. So to send and receive messages into the network and from the network, we, of course, have to set up encoders and decoders to know how we want to serialize and deserialize the messages. And it's as simple as creating encoder and creating decoder and passing it the content topic. And all of these helper functions come from one package, which is at Waku/SDK. Everything you need comes from this. Now, to subscribe to incoming messages, now that we've set up our encoders and decoders, and we already defined the message structure, actually. Going back to the interface, this is exactly the structure that we also want to use for protobuf, in case we use protobuf, right? And it's as simple as just creating a new type and adding all the fields to it. Now, assuming we also have the message structure sorted, we're going to come to sending messages in a second and focus on receiving messages from the network first, right? The function or the protocol we are interested in is the filter protocol. And let's just create a subscription object using this. Let's call this subscribe to incoming votes, as we did. And this takes in a few things, but we'll focus on writing the code to see what we want. OK, so we'll need a node for sure, right? And the node is of type a light node, and the types as well come from the same package. The next thing we want to do is, well, we have the subscription object, but when the messages come to us, we want a way to decode the messages correctly, right? So we pass it the decoder, and it's going to help us process the messages. So we pass it this, and the callback here is what you want to do with the message, right? So we're going to define a little callback here. Let's call it callback equals to, and this is going to have the decoded message. So let's call this the poll message, and it's of the type decoded message. And let's just do, well, found decoded the message, right? Cool. And the next thing we're going to do is, like, of course, pass it the callback, and that is it. That is it, right? This other thing we can do here is to get a callback from the user, right? Because the callback we've defined inside is just to decode the message. So yeah, to decode this, we're going to have to use the protobuf definition and decode using that. So the decoded message, this will be not the format we expect to get. So for that, let's see what we want. We'll want to see the poll message.payload if it exists, right? If it does not exist, well, we don't want to deal with it. If it does exist, we'll create the poll message object, which is going to be, well, p-poll message, which is our protobuf definition, and then decode using that. And yeah, so now this is going to be our deserialized message. The serialization and deserialization can seem a little bit more, adding more friction, but in reality, once you set it up for the first time, it's pretty seamless. Once we have this, then we're gonna go to sending the vote, right? We've set up how we can retrieve votes that are coming in live. Now we want to send messages into the network, or send our option into the network. So let's set that up. And this takes in what? Let's see. We're going to use light push. So we got to create a proto message. And in this case, the chat message is not right. It's called p-poll message. And the things that it wants is an ID, a question, and the answers, right? So we got to pass it in arguments, because we're going to use some front-end magic to basically just automatically send it to this function. So let's pass it a variable which is, well, our vote. And this is of the type iPoll message. And we're going to create this, our vote. And now next thing we want to do is we want to serialize this. That is done. And well, we just send it. And we want the node that we send it with. And we're going to use light push this time. So light push is to push the messages into the network, and filter is to retrieve the message from the network. The node here is going to be of the type light node. And well, that is it. The next thing is, now that we have our utility functions, right? Let's not focus on retrieving existing votes for now. But this is another protocol, which is the store protocol, right? And this comes in handy when, let's say, you're offline, but you still want to know, without being online, what are the messages that were sent while you were away. So the store protocol stores your messages for an arbitrary number of days. I think it's 30 days for now. And after 30 days, it just wipes the data away. Okay, now that we have a way to send a vote, subscribe to incoming votes, and creating a node, that is literally all we need. Going into our root of the app, right, which is page. This is our logo and some loader stuff. Now within useEffect, well, we can just remove this. We're gonna create a state, right, which is gonna hold our node, because we wanna pass this node around throughout the application, and you can use some more central state management things. But for this use case, we're just gonna stick with useState. The next thing we're gonna do is we wanna call this asynchronous function. So we're gonna do some janky stuff, and within useEffect, we're gonna create the node and set the node, and then call this function. Void is not assignable. Okay, so we actually had to return the node. We did not return the node here, right? So we returned a node here, and this error goes away. Okay, now we expect to have a Waku node initialized as soon as the app mounts. The next thing is the poll itself, right? And to simplify all of this HTML, we have a question. We have 4 options, right? The questions are being mapped on. The answers are being mapped on to render, and that is all we care about. And then there's an on click that handles the vote being sent. So what is happening, except sending the vote, is you're listening to the messages. You want to listen to the messages that are incoming, and you want to, let's say, increase a counter on your options. Now, for that, we need to subscribe to our events, for which we already have a utility function. And the second thing we need is a way to send the message into the network. So for that, let's write our handle vote send. And we have this function called send vote, right? It takes in the node itself and the vote message. There are multiple ways you can architect this. You could create a class, and then you would not have to pass the node every time. There are multiple ways you can go about this, but for simplicity, we're going to stick with this. So what you do is you get the index, you find the vote object, and all you do is you just send it, you just call this function. Now what it does in the background is it creates the proto message for this, it serializes it, and then it passes it as the payload. Now one little nuance here is that over light push, the maximum payload size is 1 MB, and not the payload size. It's actually the entire encoded, the entire serialized message cannot be over an MB. But most things should not cross an MB. It's a very generous limit in my personal opinion. Cool. Now that we know how we handle sending votes, the next thing is we're also listening to how you receive votes. And we want a counter to increase. So we have this little function that takes in the poll message that is received and finds the index for that option that is received and just increments the counter, right? Not as readable, but it is pretty straightforward. All it does is parses through the, loops through the object and finds the option and increases the counter. Now on use effect, well, we handled sending votes. The next thing we want to do is subscribing to events, right? And we have a function for that as well. Subscribe to incoming votes. That uses filter, and it takes in a callback, right? Now that callback is actually our process received votes that increases the counter. So here we're going to call our subscription function, and that is pretty much it. So just to recap, and we're going to do a little small demo of what we've built here. I know we have not focused on front end because that was not as important, and I think everybody here who's trying to play around with stuff would be able to figure that out. But what we care about here as well, we were successfully able to interact with the network, use it for a use case to propagate messages between peers, and in a decentralized manner. So the Waku network is permissionless. As Guru mentioned in the talk previously, you can operate a node right now. You can participate in the network yourself. There is no incentivization, but it is still permissionless and censorship resistant. So without using any centralized service, we were able to make a peer-to-peer application that scales. And to see how it looks like, if anybody of you have want to interact, open your phones or your laptops or any machines, and the URL is wa-poll.vercel.app. And what we've made on this application is deployed here, and the code is on the GitHub as well that we can link. And what you're going to see as you open your on your website is going to be a loader that says connecting to the network. The URL, of course, sorry. Is that visible? wa-poll.vercel.app. And as you vote, somebody voted, and we're going to see the voting counter increase. And one thing to note here is, okay, so somebody thinks the taxis are the favorite part. Well, Guru would disagree. Guru got scammed yesterday. You're the one who voted it well. So the interesting part here is that, well, there is no centralized server involved. We're connected to a decentralized network, which is peer-to-peer in nature. And, well, that concludes our presentation. The use cases are endless in terms of Waku being a networking layer. It is very modular. Chat applications are the most direct and the naive use case. And we have seen some of the community projects and partners do that. We also have, as Guru mentioned, projects like Railgun that use it for their private blockchain. Then we have Silence Labs that use it for multi-party computation. Silence Labs, yes. Not Silent Protocol, Silence Laboratories. They do multi-party computation. So we're looking for these novel use cases, and as Guru already expanded, two people seem to think taxis are the favorite part about Istanbul. Well, that is all from my side, and yeah, okay, questions, please, yes. Yes, so that is a very important point. Waku does not link any identity to your session, to your message, right? So every time you refresh, well, let's say I vote here, right? And now the input boxes are disabled. Well, that's a front-end thing, right? You can just inspect the element and you can play around with that. So to sort of enforce some sort of identity, we expect the application layer to integrate their own solutions, and that is how the sort of modularity into the protocol comes in. Waku is strictly used for the communications bit, the message propagation bit. Everything else is can be integrated with it. So you can attach a wallet here, and we have some examples on our GitHub, examples.waku.org, and some of them use wallet connection as an identity. So yeah, you can be creative, you can be novel about it, and sort of play around with it. Yes?
Yeah, how do you prevent spam?
Amazing question. So spam and DDoS protection is something Waku and its research entity WAC has been thinking about and solving for a very long time. In tandem with PSE, and Alvaro here is here, who actually implemented it for Waku. Thanks to him. So there is an algorithm called RLN, which stands for rate limiting nullifiers, which uses ZK, and he's probably the best person to answer this. So there's a membership set, and it's deployed on some chain. It's Sepolia for now. We're testing it out on a testnet. Yeah. And you register into the membership set, then every time you send a message, you have your proof attached to your message, right? And it is capped. There's a cap on the number of messages you can send into the network. And anything that does not have a proof attached will still be able to send, but it'll not be prioritized. Is that correct, Alvaro?
Yeah, we are still thinking about that feature.
Yeah.
What we have right now is that if you exceed the limit that RLN imposes to you, then your message is going to be discarded. And any peer that sends invalid messages or spam messages, we have a scoring system, and we will score your peer, and the rest of the peers will end up kicking out you the network. So at this point, we don't have any free bandwidth that you can use without these RLN proofs. But this is not imminent yet. We are releasing this next week.
So there is a type of identity anyway.
It's a pseudo identity because it's not connected to any on-chain identity. Because in the zero-knowledge proof that you attach into the message, you prove that you belong to a given tree of whitelist identities, but you don't reveal your identity. And assuming that you broadcast, you have to register your membership on chain, right? Assuming that you broadcast this message that inserts your membership into this tree with a gas station, if you're aware of this, no one will be able to map the message with any on-chain identity. So it's very, very relevant.
And anybody can create these groups?
Yes, we have a contract. You have to pay some fees, and then you can join. But it's permissionless. And we will be releasing a testnet. We have the testnet, but we haven't announced it yet. So if you're interested in that, next week, stay tuned to our Discord. We will announce it.
Do you want to open the QI for the Discord? Any other questions? All right, thank you so much. We'll be around we have a booth on the left. We'll be around to entertain any questions, any sort of help you might want. And of course, Discord is also a great place to get very prompt assistance. All right, thank you so much.